Good afternoon, everybody. But online can hear me, can see the screen versus online. Versus online, can you hear me? Can you see the screen?
The screen is blank so far, sir. Good evening.
Can you see it now? Is it a white screen?
It is a white screen.
All right. If I make a mark like that, you see that?
Yes, sir.
All right. So good to go. All right. So we're going to be having a series of revision sessions with an aim of basically clearing up some of the misunderstandings and so on some of these topics, some of the main topics. Today we're looking at bearings and circuit theory. Tomorrow we're looking at, what was it, vectors and matrices. I don't remember, but I'll see what it is tomorrow. And the plan is to have additional sessions next week and the week after, leading into the exam. All right, I want to cover at least 8 of the main topics. Just to, clarify, the very last one is going to be like a freelance sort of session where persons will be allowed to bring their questions, a last chance to, ask for clarity on anything. All right, that is the aim. So I'm basically going to be leading off with these topics. These are the topics that I find persons just tend to have some difficulty with, but they are actually really very easy. And to make them easy, there are just a few basic things you need to pay attention to, and then they'll become easy. All right, so the first topic we're going to look at, and what I'm going to do in this session, I'm just going to give a brief overview, almost like a little crash course of the main things they look for, the main things to consider in a bearings question. Another circuit here is going to be the same thing. Maybe 10 minutes or more, just the main things they look for in a bearings question. And they will look at what the general approach is to doing a bearings question. The majority of bearings questions are pretty much the same. They're for the asking the same sequence of things, right? The aim is to do maybe 5 or 6 past paper questions, and we're talking about the more recent past paper questions, about 5 or 6 of them, and then might take a short break, and then we'll go into circuit theory today. So that is the plan. All right, so let's talk about bearings a little bit to start. All right, bearings will always come in the section 2 as a structured question. It also comes on the multiple choice, for some little minor questions on the multiple choice. But the main will come in section 2, number 9, the trigonometry question. Because bearings is a topic that seeks to apply sine rule and cosine rule. And sine rule or cosine rule are used when you're doing trigonometry on triangles that are not right angled. So once a triangle is not a right angle triangle, then you have to use sine rule and cosine rule. And so bearings is the application topic for the use of sine rule and cosine rule mainly. Because bearings is a real life subject, something that is used in the real world. All right. So what are some of the main things to look for? But the first thing in a bearings, you must have a north line. You cannot be doing a bearings question and not have a north direction. The north direction is a reference direction in bearings. So for example, if they ask you to draw a bearings diagram, you must have the north direction station in it, or shown in it. All right? That's the first thing, the north line. The next thing we have to look out for in bearings is what we call the from position. The from position. So the question will always say something like the bearing of A from B. Your focus is on here, the from position. The bearing angle is measured at the from position. It's almost like everything is taking place at the from position. So you have to focus on the from position. And sometimes they will say from B to A. Still, this is the from position. All right? All right, so that's the next step. I'm going to put one or two small examples on the board to see sometimes how we can deduce other angles from a bearing angle presented. Remember that bearing is a clockwise angle from the north direction to the line connecting 2 points. So for example, if the bearing of B from A is 0, 30 degrees. And why did I write the 0 here? Because bearings must always be given in 3 digits. 0, 30 degrees. So if the angle is 30 degrees, then the bearing is 0, 30 degrees. If I were to show this information on a simple diagram, the from position is A. So I'm putting down my A first. Then I need to show a north line at A. So this is my north line at A. And then I'm measuring 30 degrees to the right from the north line. It's like you're turning to the right. So it will be 30 degrees this way. And so B would be somewhere up here. B will be somewhere up here. And so this angle, mute your mic please, mute your mic please. This is the angle that is 30 degrees, which then would be 0, 30 degrees. Now from this situation alone, there's a number of things that we can deduce from this situation. Oftentimes, what they'll do also is give it the distance. So for example, I might say the distance is, say, 5 kilometers. So it would mean that this distance is 5 kilometers. But I'm not focusing on the distance right now. I'm focusing on the angle, because it is the angle that gives persons problems from time to time. Let me shift this around a little bit and show some of the other considerations that we can make. All right, so what are some of the other considerations that we can make? Use a different color. What if from this example, they want us now to determine the bearing the other way? From B now to A. So this now is a from position. Given this bearing, how can we find the bearing from B back to A? It's quite simple. First thing, you would need the north line at that from position B. So let me just shift this a little bit. Put B right here. And so we would need a north line at B right here. From position. I'm going to draw the north lines in red, just for emphasis. I'm going to put this north line in red. And also put this north line in red.
Suspect's hesitation and long breaks before answering.
All right. We're back. All right, hold on a second. Let me just fix something on this device. Hold on a second. Just hold on a second. Another internet problem here. Just hold on a second.
Specifically, that's American Civil War from 1863. Is that filled to win out the sequel from the 1800s? Stupid. If it was a sequel of 1863,
All right, ready again. All right, sorry about that, guys. A bit of internet problem. So let's try the hotspot. See that will work better. All right, please mute your mic. Please mute your mic. Please mute your mic. All right. So I'm saying from this information that we have so far, yes? Huh? Who can hear me? Oh, the other not on? It's on. No, they can't hear me here. It's not on that, but it's on this. Can you hear mine, people?
Yes, sir.
You can hear me? Yeah. What you're seeing is on that device. All right, let's go. Relax now. Let's go. All right, so let's continue. So if you want to know the bearing from B to A, sometimes what you want to do is show the angle that you want. Here back to here, you want the bearing. And so that again, remember, is clockwise from the north and at the from position. This is now your from position. So you would want this angle around here. That is the angle that you want. And there are a number of ways you can find that angle. Now, there are some telling things that we have when we have these two parallel lines. Because once you have parallel lines, we have situations where we can set up Z angles, and we can set up what we call U angles. The Z angles are equal, the U angles are supplementary. They add up to 180 degrees. Let's form some Z angles right now. We can form Z angles by extending this line, for example. So if we think of it as coming down this parallel line, up this line, joining those lines, and then coming down this one, then we would have formed Z angles in here. So it means that this angle in here would also be 30 degrees, just like this one. Those are your Z angles. Then the U angles that are formed are the angles in what we call a U. They actually call, the proper name for them actually are co-interior angles. And it's as if we form a U using these two parallel lines and this line joining them. So it's like we go like this and we have formed a U. The angles in the U right here, they are supplementary. They add up to 180 degrees. So it means that this angle plus this angle, both of them would add up to 180 degrees. And so since this angle is 30, it simply means that this one is 180 minus 30, which will become 150 degrees. It is 180 degrees minus 30 degrees. And that's an angle that is useful. Because now that we know that angle, then the bearing angle that we want, which is the angle around here, will now simply be 360 degrees minus this 150. 360 degrees minus 150 degrees. Why? Because the total angle around a point is 360. That's one way to do it. Another way that we can do it is this. I'll show you another way we can find the bearing angle. So if we use the Z instead, by extending this line down, this north line, extend it down to create the Z angle inside here, then it means that inside here will be 30 degrees as well. And then on this side would be 100 degrees. Angle on a straight line is 100 degrees. And so the bearing angle, this is 180 degrees, sorry, this should be 180 degrees. Angle on a straight line. And so the bearing angle, let's show it in a different color. Let's show it in purple, which is this angle all the way around here now. Back to B. That's a bearing from B to A, back to A. Would then be 180 plus this 30. And so that's another way we can do it. 180 plus 30. All right? There's yet another way that we can do it. There's yet another way that we can do it. So I'm showing you to use the Z angle to do it, and U angle to do it. I'm going to show another way to do it. So the other way I want to show you to do it is that this line from A to B is on a bearing of 0, 30 degrees everywhere. At this point, the bearing is still 30 degrees right here, because that's a north line. Anywhere on this line, the bearing is going to be 30 degrees, 0, 30 degrees. And so if I take this line and I extend it further this way, the same line, you know, so I'm sure basically that's the direction of that line. That means that this angle is still 30 degrees, just like here. Because the bearing of this line is forever 0, 30 degrees. And so this angle up here is also 30 degrees. And the bearing angle that we want, and if this angle is 30 degrees, you know, remember now that from here to here is 180. Because that's a straight here. Would be the sum of the 30 degrees and the 180 degrees. Would now be the bearing from B to A. So I've just shown you 3 different ways to get the bearing from B to A, if you know the bearing from A to B. All right? All right, let's move to something else. There are some common things that you need to know. The bearing of north is 0, 0, 0 degrees. The bearing of north, bearing of north. The north direction is 0, 0, 0 degrees. The bearing of east, so if something is going towards the east, it is going a bearing of 0, 90 degrees. Because remember, this is the these are your cardinal direction. North is this way. You always spell we across here. From west to east, you spell we. So east is to the right of north. If you turn 90 degrees, if you face north first and turn 90 degrees to the right, you'll be facing east. And then if you face north, then south is behind you. So south is here. So south is on a bearing of 180 degrees, but you have to turn 180 degrees to face south. So south is on a bearing of 180 degrees. And then if you want to face east after west, after facing north first, then that bearing will be all the way around here, 270 degrees. But these are things that you just know. So the bearing of west is 270 degrees. All right? So if something is going towards the west, it's on a bearing of 270 degrees. Let's showing you a few more things before we start doing the questions. If something is going due east, like if a question says something like A is due east of B. A is due east of B. These are some terminologies that they like to use. Due east or due south or due west. The word due simply means towards. And of B means from B. So this means from B, just the same. And this means towards. These are some terms that we need to understand in the bearings question that they'll use. So if A is due east of B, it means that A is towards the east from B. So it means that B is here and A is over here towards the east. So if B is the from position, I have a north line at B, then it means that the bearing here to east is 090 degrees. Because the bearing of A from B is 090 degrees, it's towards the east. So remember, due means towards, and of B, for example, means from B. These are some terminologies that get people sometimes, they don't understand these terms when they see them in question. We're going to see them in the question. All right? All right. What else I want to talk about before we start? Yes? Huh? If they said B from A, then that means that the A will be over here. But this one is A is due east of B. A is due east of B. Means that A is towards the east from B. You understand? So it means that A is on the east side of B. All right. All right, let me show you something else now. I'm just going through a couple of things. All right. Let's go back to the situation where we had the 30 degrees from A to B, right? So we had A right here, and B was on a bearing of 30 degrees from it. So this was the north line at A, and the bearing here is 030 degrees. So this is 030 degrees. 030 degrees. All right? Now, sometimes they might say a question like, how far due east is B from A? Let me write it out. How far due east is B from A? What do you think this distance is asking you for? It is asking you, recording stop. I want this to be recorded. Why did it stop? Let me just check something. Let me check something, guys. I just read a message recording stops. Let me just check something. I want it to be recorded so persons can have it to look back at afterwards. All right. All right, cool. Right. So this is referring to actually the distance this way. If I were to show a north line down here, this is referring to this distance. That's how far east B is from A. So this will be referring to this distance, this statement. Referring to this statement. And so, because this is a north-south line and this is an east-west line, this will become a right-angle triangle. Mute your mic, please. Mute your mic. This will be a north line. This will be a 90 degrees, sorry. And if you know this distance, then you can use Pythagoras' theorem or Sokar tower in this triangle to find this distance. If they ask another question, like for example, how far due north is B from how far north? In other words, from A to B, how far north do you have to go to reach the level of B? You can look at it that way. It is talking about this distance up here, because this is how far north you have to go. This distance it's talking about now, this one. How far north it is. This will be the distance it's talking about. This question is talking about this distance. Again, in this triangle, you would use Sokar tower or Pythagoras theorem, because this is a right angle triangle to calculate this, how far north it is. Or they could have said how far south from B is A. Still this distance we're talking about. Or they said how far west from B is A. Still they're talking about this distance. All right? So sometimes they ask those things. All right? What else do I want to talk about? All right. So I've spoken about the Z angles, the U angles, the 3 digits, the from position, the north line, how far north, due, west, east, and so on. And I show you how you can get one bearing from another bearing angle. Let's just do another example of that with some numbers. So just one more example of that. So for example, if they gave us a bearing from A to B, let's make it an angle of, say, 150 degrees. From A to B, the bearing is 150 degrees. If I were to sketch this, A again is my from position right here. This is my north line at the from position. This is A. That's my north line at A. I now want 150 degrees clockwise. Remember, right here is 90, you know. So 150 has to be somewhere down here. So if I were to show it, this is A, then B will be somewhere down here. And so this angle would be 150 degrees. That's a bearing of B from A. And suppose I want to reverse it and ask for the bearing back from B to A. They want the bearing now from B to A. So again, you have to draw your north line at B this way. And the angle that you would want is this angle all the way around here. That's the angle that you would want. Again, that's pretty easy because remember, the angles in the U right here, if you come down this north line, go along this side AB, go back up this north line here, then you have the angles in the U. These two angles again add up to 180 degrees. They are supplementary. And so since this angle is 150, then this one has to be 30. And then again, total angle around the point is 360. And so this bearing angle going the other way would simply be 360 degrees minus this 30 degrees in here. So that's another example if you want to reverse the bearing angle at the axis, or reverse the direction of the bearing. All right? But what I want to look at now is sine rule and cosine rule. All right? Let's look now at sine rule, cosine rule. All right? Now, the majority of the bearings questions are set up such that you're going to have to use cosine rule first. So let's talk about that a little bit. So let's say I give you some information. I'm going to use some numbers as an example, for the example. Right? Let's say I give us some information. And you have a diagram looking like this. From A to B. And then from B to C down here. So from A to B. And then from B to C. Such that you have from B to C. Such that you have this distance AB. And let's say in this example, what do you know? Let's say you know the bearing from here to here first. And let's use simple numbers. Let's say it is 30 degrees again. So from the north line, let's say this bearing again is 30 degrees. Just using a simple number for illustration purposes. So let's say this is 30 degrees, here 30 degrees. That's that angle. And let's say from B to A, let's give it a value This is B. And I want the bearing from B now to C. Let's say that this is say 160. Just give it an angle. So this is 160 degrees. Let's say that this is 160 degrees. That bearing is 160 degrees. That's information presented. And they will more than likely give you this distance and this distance. Let's say that they give you two distances. Let's use some simple numbers. Let's say that this distance is 10 kilometers. And let's say that this distance is 15 kilometers. So naturally, what they're going to ask you for is this distance, AC. All right? So to find this distance AC, we're going to need an angle inside the triangle. This angle inside here would help us a lot. Because if we get that angle, we have a situation then where we would have two sides and an angle between. And that's the typical case for the cosine rule, when you have two sides and an angle between. So question is, how can we get that angle? Now, some questions are going to ask for this angle. Some questions won't ask for that angle. They just ask for this distance. And you have to know that you have to calculate and find that angle. But how can you find that angle? Easy. Because remember, we have, once you know this angle, you can find this one up here. Co-interior angles, the U angles. So the angles in the U. If this angle is 30, then this angle is easy to find. It's 180 minus 30. These two angles will always add up to 180. So then this angle up here would be 180 degrees minus 30, which is 150 degrees. 180 degrees minus the 30 degrees that we have equals this 150. And then now, if you want to find this angle in here, this purple angle inside here, it will be 360 degrees minus the sum of these two. Why? Because the total angle around this B point is 360. And if you already know this one and this one over here, then the one in between those two sides will be 360 minus the sum of those two. So you're subtracting the 160, and you're also subtracting the 150. So much that you're subtracting? 310. So it means that the angle between there is 50 degrees. So this angle inside here is 50 degrees. So you know the typical case for the use of the cosine rule, yes? You could use the Z angles as well. All right, so somebody is saying another way you could do it. Very good. All right, let's show the other way you could do it. But the other way we could do it, all right, let's leave that and show the other way. So the other way we could do it is to generate the Z angle. Let me use a different color for the Z angle. Let me use green and show that we could use the Z angle as well. We're going to use the Z angle. Then what would that mean is that we would come down this side, go back up here, and draw the vertical line and break this angle right here. And then now the angle on this side will be equal to the 30 degrees over here, 30 degrees. And then on this side totally will be 180 degrees. Remember, part of it is already 60. So it means that inside here will be 20 degrees. And so the total angle between the two sides will be 50 as well. 30 plus 50. So yes, that's another way to do it, using the Z. All right? Very good. All right, let's go back. So I found that it is 50 degrees, whichever way. So now that you know that it is 50 degrees, a lot of persons have problem deciding whether it is the sine rule or the cosine they must use inside here now. Remember, you cannot use SOHCAHTOA tower now in this triangle because it is not a right angle triangle. You also cannot use Pythagoras' theorem in it. It is not a right angle triangle. You have to use either the sine rule or the cosine rule. So how do I know that I must use the cosine rule? I can say, okay, I am eliminating the sine rule. Because to use the sine rule, let me show you. To use the sine rule in any triangle, let's do a little sketch right here. If I have a triangle and I'm going to use a sine rule, it is as if I have to know an angle and also know the side opposite to it. These two things opposite each other must be known. You must have a known pair of angle and side opposite each other to use the sine rule, to use the sine rule. That's what you must have. A known angle and side that are opposite to each other. In a triangle that is not a right angle triangle. That's when you use the sine rule. We don't have that here. The angle that we know right here, it is 50 degrees. This angle that we know, the side opposite to it, we don't know it. This side that we know, we don't know the angle opposite to it. This side that we know, we don't know the angle opposite to it. We cannot use the sine rule first up as it is now. But still, this is a typical case for the use of the cosine rule when you have two sides and an angle between. So we're going to be using the cosine rule for here. Now, a lot of people depend on a formula sheet for the cosine rule. You don't need no formula sheet for the cosine rule. The cosine rule starts out like Pythagoras' theorem. The cosine rule starts out like Pythagoras' theorem. And you have to subtract a piece, because the angle here is not quite 90 degrees. So if I'm trying to find this side, it would have been that AC would be equal to the square root of this side squared plus this side squared initially. If it was Pythagoras' theorem, 10 squared plus 15 squared. But it is not a right angle triangle. It is not Pythagoras' theorem. I have to subtract a piece. It's just for us to remember the piece that we're subtracting. We are subtracting twice the product of those two sides times the cosine of the angle between them. It's easy to remember. Twice the product of the two sides times the cosine of the 50 degrees between them, in this case. And that's how we can find, that's how we can find AC using the cosine rule. See here, it starts out like Pythagoras' theorem. Let me erase this again. Starts out like Pythagoras' theorem. As if you're trying to find the hypotenuse. Remember, this angle inside here is 50 degrees, and it is not 90. It is not 90 degrees, it's just 50 degrees. So it starts as if you're finding the hypotenuse in Pythagoras' theorem. But it's not the hypotenuse in a right angle triangle. So you have to subtract a piece. So you're subtracting a piece. And the piece, you just have to remember that the piece that you're subtracting is twice the product of those two sides times the cosine of the angle between them, which is the 50 degrees. And so that's how we get the AC. You don't need to look at no formula sheet for the cosine rule. And then now, when you have this, guys, you don't go calculating each part. You don't need to do that. You put everything in the calculator and do one calculation. So let me bring up the calculator now. So your calculator can accommodate the fullness of this expression. Make sure your calculator has one of those types. We call it the textbook display calculator, that you can type this in there and it appears as it is on paper. So that will be the square root of the 10 squared plus the 15 squared minus 2 times the 10 times the 15 times the cosine of the 50 degrees. And it tells me that that is 11.3 significant figures, 11.5 kilometers. All right? And that would be 11.5 kilometers. That would be this distance right here. And as soon as you find it, you put it on the diagram. As soon as you calculate it, you put it on the diagram. So I now know that this length is 11.5 kilometers. So typically, that's how a bearings question will start out, asking you for a distance. Now, what they'll do sometimes is now ask you for another angle, which is a bearing angle. Now, look at it now. Give you a little hint. This is the triangle that we have now. So going forward, any calculation we're doing in this triangle going forward, we are now able to use the sine rule. Why? Because we now have this pair of angle and side that are opposite each other. Then put them in a different color for you. We now have that pair. Angle and side opposite each other. We know both of them. Angle and side opposite each other. Once you have that, a known angle and side that are opposite each other, where you know the angle, you know the side, you can use the sine rule going forward. The only thing we don't know in this triangle now are these two angles, this one and this one. We know the three sides, and we know this one angle. So it's only this angle and this angle we don't know now. So oftentimes, the next question will require you to find either this angle or this angle, one of them, one or the other. So how you know which one you're most likely you're gonna need to find? Let's say the next question is for you to find the bearing, say from A down to C now. Let's say the next part of the question is for you to find the bearing from A to C. Let's write it out. Now let me take this off the diagram. So let's say the next question, after we find this distance, this is how the bearings questions typically set up. You know, these things that I'm explaining to you. That's how the bearings questions are typically set up. So the next question might be to find the bearing from A to C. So I might ask you for the bearing from A to C. All right, listen to this hint now. Let me write it out this way. Bearing, you might write it this way in the exam. This is how the normal word is. The bearing of C from A. You have to note the from position. We want the bearing from A. I want it to C. So you're gonna do your bearing at A. Since you want your bearing at A, it means that more than likely the angle inside the triangle at the point A is going to play a part in your calculation going forward. So this angle inside the triangle at A, because you want the bearing from A down to C. So the angle inside the triangle at A will 95% of the time play a part in this calculation. Not 100% of the time, and about 95% of the time, depending on the information that you have. But typically, that is what would happen. So you like to know that you're going to need this angle. So I normally just call it alpha. The angle inside the triangle that I know that I'm going to want. And you must mark this bearing angle that they're asking you for. Mark it on the diagram. So this angle that they want, the bearing of C from A. So the C here, and I want it from A down to C. So the bearing is measured at the from position A. So that angle that they want, let me mark it in a different color. Let's mark it in blue. It is this angle from the north line at A, clockwise. Let me use a different color still. Let me use this. I have too many colors. Let me use this purple or this green. Is it from the north line clockwise down to the line that is taking you to C? This green angle is the angle that question is asking for. The bearing of C from A. All of that angle. Let's call it theta, so we can reference it. That angle theta is the sum of the 30 degrees in here and the alpha. So that is how we know we need the alpha. Remember, to find the alpha, we're going to be using the sine rule. Why? Because we have this pair of angle and side opposite each other that we're going to use. So let's look at the pair that we're using the sine rule. So we know that we're going to find the theta by adding the alpha and the 30 degrees. All right? Let me take it off now. Let me take off the theta on the diagram here. Let's put out here, theta. So we're going to be using this angle with this side across here in the sine rule, this angle with this side opposite to it, and this angle with this side opposite to it in the sine rule. Okay, it's a ratio relationship between the sine of the angle and the side opposite in the sine rule to find the alpha. Because once we find the alpha, we're going to get this green angle that we want, the bearing angle that we want. All right? So let's go down and do it now. Mute the mic, please. Somebody mic is open. Mute the mic, please. So I'm saying the bearing of C from A on the diagram is theta. I can say it here, is theta, where the theta is equal to the 30 degrees. See it here? This 30 degrees plus this alpha. 30 degrees plus the alpha. I will try to find the alpha. Let's break away and find the alpha. So we're going to find the alpha using the sine rule. Using the sine rule. So since it's the alpha that we want, I always say start your sine rule with what you want to find. So we're going to put sine of alpha. We're going to put sine of alpha over the side opposite to the alpha. Let's look back at it. So the alpha here, the side opposite to the alpha is the 15. So it's the sine of alpha over the 15. Equals sine of the angle that we know. The angle that we know is this one, 50 degrees, over the side opposite to it, which is 11.5. So the second pair is the sine of 50 degrees over the side opposite to the 50 degrees is 11.5. That's your equation to find the alpha. It's now a matter of transposing to make the alpha the subject. Easy. You take the 15 and you're going to multiply it up here first. Cross multiply. Let's go step by step. We'll do it as a first step. We're going to get sine of alpha equals the 15 times the sine of 50 degrees divided by the 11.5. And look here. I'm not going to work out anything until the end. Now. There's no need to be working out each part and working out that part. We can save our calculation to the end to do one calculation at the end. If sine of alpha is now equal to this, then the alpha is sine to the -1 of that, the inverse sine. So then I can write that the alpha is now sine to the -1 of this whole thing. 15 sine of 50 degrees divided by 11.5. And I can put this in the calculator and get my angle alpha. So let's do that now. So back to the calculator. Make sure your calculator is in degrees. I'm going to do this calculation. So I'm going to put sine to the -1. I'm going to put a fraction in the calculator. 15 sine of 50. Make sure the calculator is in degrees. If you look up here, you're going to see the DEG on top there. And then you put in that over the 11.5. The calculator gives us 87.69. That's 87.7. You go for one decimal place or three significant figures if the answer is not exact. In case of angles in degrees, you go for one decimal place. Generally speaking, you go for three significant figures. So I'm going to write this as 87.7 degrees. And this is the angle now that I'm using back up here for the alpha. And so I can complete this calculation for the bearing angle. The theta angle bearing angle that I've marked on my diagram is now 30 degrees plus 87.7 degrees. That is my bearing angle. I just need to add 30 to this. 117.7 degrees. But don't leave the answer like this because we're doing bearings and they ask us for a bearing angle. Bearings is normally given to 3 digits. So just correct this to the nearest 3 digits. And you're going to write your answer as 118 degrees. And this would be the answer, the bearing from A to C. Typically, that is your bearings question that we just did. Typically, that's your bearing question. Any questions so far? Very good so far? That's the extent of a bearings question for the most part. We just need to do a couple questions now. All right? Just need to do a couple questions now. Online, everybody okay? Online? People online okay?
Yes, sir.
Yes, sir.
All right. So we're going to do a couple past paper questions, guys. So I'm going to find a couple past papers in this device here. I'm going to do a couple past paper questions. More math equals better math. Some of you here would have seen these questions already. No problem. It is revision. Clarifying anything. Remember, if you have any questions, you ask. Anything not clear, this is the time to ask. We're going on to something different after a while, right? Circle theory. It is being recorded, so you can go back and watch this later if you want. All right. So I'm going to look at January 2021. I think I've selected a couple questions. So this one. So this is January 2021. There's a bearings question on it. There you go. Here's a bearings question. And the majority of questions these days, they actually give you a diagram. In the past, when they give bearings questions, the diagrams, we'd have to draw the diagrams. But now, they tend to be giving the diagrams. All right? So let's look at this question right here. All right? We're going to be doing this topic afterwards. Circle theory. All right? All right. So this question says, from a harbor H, the bearing of 2 buoys S and K. So remember now, this is the from position, is from H, you know. That's the from position. They're giving the bearing from H to S and from H to Q. And they are 180 degrees and 311 degrees respectively. It says Q is 5.4 kilometers from H. So this is basically a distance QH or HQ. This is a distance HQ that just gave us. And while S is 3.5 from H, so this distance now is actually a distance HS. That's what they're giving us. This is the bearing from S. This one is, no, it's not from S. This is one to S. So remember, it is from here. This one is to S. And this one is to Q. You have to note these things. From S, not to S and to Q. And both of them is from H. All right? Question said, on the diagram below, which shows the sketch of information, insert the values marked angle QHS. Now, what it is in this diagram, they have shown us the angle for 180 degrees. See? It's the bearing from H down to S, which makes sense on this diagram. Because if you look at it, H is the from position right here. You have the north line at H. As the angle to which you have to turn to the right to face S down here. So that 180 degrees is correct. What they have not shown is the 311 degrees to Q. So Q up here, sir. And this is H. So I'm going to show this 311 degrees on this diagram. This is the north line at the front position H. It will be this clockwise angle all the way around here to the line out to Q. That angle is 311 degrees. That's the one that they did not show. 311 degrees. And that's the premise on which you're going to find angle between here, because if all of this is 311 and to here is 180, then the angle inside here is the difference. 311 minus the 180. All right? Because everything is 311, and just to this part is 185, not 180, 185. And so inside here is 311 minus 180. Hope everybody can see that. So the angle that I want inside here, let's do the calculation, is 311 degrees minus 185 degrees. Somebody tell me what that work out to. Huh? How much? 126. All right, thanks. 126 degrees. Let's shift this over a bit. So that angle there that they're asking us for is 126. 126 degrees. All right? Everybody say we'll get this. All of this is 311. To right here is 185. And so the in between here is the difference. I'm going to put it on the diagram now. 126. So inside here is 126 degrees. Let's also put on these distances. Move to back of my eye, please. The distance HQ is 5.4. That's right here. Let's put it on the diagram. 5.4. Let's put it on in blue. That's 5.4 kilometers right here. Let's write it like this. 5.4. And the other distance down here from Q to S is 3.5. Down here is 3.5. So the only thing we don't know right now, the only distance we don't know is this one, Q to S. The question is going to ask us for that distance for sure. This again is a cosine rule situation. We have two sides and the angle between them. Cosine rule will find this one over here. Let's see what they're asking us down here. See? Calculate QS, the distance between the two buoys. All right? So it's cosine rule that we'll have to use right here. Let's do it on the screen where the diagram is, right here. Let's do it. We're going to be using cosine rule. All right? So cosine rule. Remember, it starts out like Pythagoras' theorem. It's easy to remember. I don't need no formula sheet. QS becomes the square root. Treat it like an hypotenuse first. The square root of this side squared plus that side squared. 5.4 squared. I need some more space. Let's put it here. QS will be the square root of this side squared plus that side squared, like Pythagoras' theorem. 5.4 squared plus 3.5 squared. Starts like Pythagoras' theorem, but it is not Pythagoras' theorem. You have to subtract a piece. So you subtract twice the product of the two sides, which is the 5.4 and the 3.5 going into the diagram, and then you do the cosine of the angle between them, which is the 126 degrees. So you square root in all of that. Let's shift it down. This is it. Cosine rule. Giving us QS. And again, don't bother waste time working out it piece by piece. That's waste of time to work it out piece by piece. Make sure you have a calculator that can write all of this in it and do one calculation and get the value. One calculation needed. All right? So if I bring up my calculator, and I'm putting this in the calculator, it's going to be the square root of 5.4 squared plus 3.5 squared, as if it was Pythagoras theorem, but it is not. So I have to subtract a piece. 2 times the 5.4 times the 3.5 times the cosine of the one angle between them, which is the 126. That is 7.98, if I correct it to 3 significant figures. All right? So my QS, did they tell me how accurate must give it? No, they didn't. So they give it to 3 significant figures. All right? So I'm going to write QS is 7.98 kilometers. And I'm going to move this on to the next page now, where it is supposed to be. And you see, so the small amount of space they give for it to work, they don't expect 4 lines of calculation. They expect it to be able to do this at this level. You don't need 5 lines of calculation. Some people working out this part in here and working out this part in here. You don't need to be doing all of that. 1 calculation and you're done. All right? See, this question is typical. Next part here, calculate the bearing. Let's look at it now. Oh, remember, as you calculate the distance, get in the habit of putting it on the diagram. Let's put that 7.98 on the diagram. So you're going to put it here on the diagram. 7.98. So this side is now equal to 7.98 kilometers. And now that we know the 3 sides, we have this one angle in between here, we can use sine rule going forward because we now have this pair. Angle and side opposite each other. We know both of them. So our remaining calculation in this triangle is sine rule. The only thing we don't know in this triangle right now are these 2 angles here and there. Those are the only thing in that triangle that we don't know. And more than likely, we'll have to find one of them for the next part. Let's see. Question says we have to calculate the bearing of S from Q. Let's zoom in on this. We want the bearing from Q to S. It's very important that you mark the from position. And you're going to show this angle on your diagram. Don't just start calculating. Show this angle that they want on the diagram. So if you make a mistake, at least you get some marks. You see that you're on the right track. You were doing the right thing. I'm going to call it theta from now. So let's say I'm going to tell him that this is theta. And show that angle theta on my diagram. I'm telling him that I'm calling it theta. I'm going to show the bearing from Q to S on the diagram. So go back up on the diagram now. I'm going to show that angle. So where is Q? So Q right up here, so. What do we always say? If you want the bearing from Q, then more than likely, the angle inside the triangle at Q will play a part in the calculation. So I'm going to mark it from now, I'm going to call it alpha. Then I'm going to show the angle that they want. So that angle that they want, I need to put in the north line at Q as my from position. Let's do it in blue. So I'm going to put in my north line at the from position here. Show the angle that they want. And the angle that they want is this angle. All of this angle down here. They want. Right? Hope everybody can see that. Down to S. See? That is the angle that will take you from Q down to S. So it is that angle that they want. Look at it carefully. From this line, north line, to this line. This angle is the angle that I want, that I've marked in purple. If I wanted, I could have shown it all the way out here, if you want. I may put this a little smaller. Let's put this a little bit smaller. Put the alpha inside here. This is the angle that we're going to calculate, that we're going to need. But the angle that we want for the bearing is this angle. Bearing angle. We're going to call it theta. All right. So what else do we need to calculate the angle theta? It will be good if we can find this part of it. can find this part of the angle right here. Can you find that angle? Yes, because look at this now. Remember, everything around here was 311, you know. Right? Everything around here was 311. Let's not forget that. So we basically know the angle inside here is 360 minus 311. Because total angle around the point will be 360. Up to here is 311. Now if I show this U angle in red, look at it. This angle inside here and this angle up here, they add up to 180 degrees. Two of them add up to 180 degrees. All right? And so if I know this angle in here, then I can find this one over here by doing 180 minus this one. So let's do it. What is this angle here? This angle here is 360 degrees minus 311. But understand that? But understand that? 360 minus 311, what is that equal to?
49 degrees.
49 degrees. And then now this red angle up here, they add up to 180. So it means that this angle inside here now, inside here, is 180 minus this 49. It's 180 degrees minus that 49 degrees. Now, this is not the only way to do it, but I think this is a simple enough way to do it. What is work out to now? 180 minus 49 is how much?
131.
131 degrees. So can we see now that this bearing angle that I want is 131 plus alpha? It's the sum of the 131 right here plus the alpha right there. So this bearing angle that I want is basically equal to the 131 plus the alpha. And to find the alpha, we're going to use sine rule inside the triangle. Now, all these markings, I'm leaving them on my diagram. And all these markings, it's a part of my solution. I'm leaving them on my diagram. Right? I'm leaving all those markings on my diagram. It's a part of my solution. You get me? That's not the only way to do it, guys. Don't get me wrong. That's not the only way to do it. All right? Let me just stress that. But this is an easy enough way to do it. So I'm going to calculate the alpha and then add it to the 131 and we're going to get the bearing angle. So let's go back down here now. We're doing the calculation. So we're calling it theta. I want to tell the examiner now that that angle theta on our diagram is 131 degrees plus the alpha. We need to calculate the alpha. It's the same thing again like the previous question. We want to use sine rule for the alpha. All right, let's look at the side and angle that we're using. So we're using the alpha with this side across here. And we're using the 126 with this side across here. Let's write it out on this page and then copy it down. So it's going to be sine of alpha over the side opposite the alpha is a 3.5 equal the sine of the angle that we know, which is 126 degrees over the side opposite the 126 is that 7.98. This will give you alpha. Let's copy this down. And put it here. We're doing our calculation. Right here. And then the transposition here again is the same. Now we can actually transpose this in one step, guys, to do it quickly, Remember, it's the same calculation. We're going to multiply the 3.5 first, and then we're going to take the inverse sign to leave alpha as a subject. So we can literally cut out a step. And we have to practice cutting out these steps. So the alpha, let's write it. The alpha is going to be sine to the -1 of. When this 3.5 come up here, it's going to become 3.5 sine of 126 degrees over this 7.98. And that is the calculation that we're doing. And get the alpha. Put this calculation in the calculator now. So we're going to do sine to the minus 1. Sine to the minus 1 of a fraction is 3.5 times the sine of 126. And dividing that by 7.98. That gives us 20.8 degrees. 20.8 degrees if you write it to 3 significant figures. We're using this value on the alpha right here to get the angle. So then our bearing angle that we want, theta, is simply now 131 degrees plus that 20.8 equals, that's 151.8 degrees. But because we give our bearing angles to 3 digits, we're going to round it up to 152 degrees. And put that as our answer right there, this thing. But go to that. But okay.
Yeah.
Why did you round up the 2?
Yes, because bearings as a rule, as a practice, is given to 3 digits. So even if you do a question and you get 56 degrees as your answer, you put a 0 in front of it for bearings. If you get, if you're doing a bearings question and you get 53.8 degrees as your angle, as your bearing angle, to express it as a bearing, you would put 0.54 as a practice. Bearings are normally given to 3 digits because bearings really is about locating points on the surface of the earth, you know. And the idea is that the 0.2 degrees between here and here is insignificant. And say that instead of saying, for example, 0.53.8 degrees, in the real world, in practice, they would basically just say 0.54 degrees. So bearings is normally just given to 3 digits. 3 digits. That answers the question?
But if the answer was 151.78,
151.78. This?
Yes.
152 same way.
Okay.
3 digits. 3 digits. Your aim is to get 3 digits. 3 digits. All right. Okay. Better go to this one. Any other question on this one? But all right. Very good. All right. Let's look at another one, just like the other one. Let's look at May 2021 then. May 2021. June 2021. More maths equals better maths. Let's look at May 2021. So this is just supposed to be just revision for you guys. And maybe clearing up stuff. If there's anything you don't, not quite certain about. All right, 2021. All right. So 2021. Let's find the bearings question on this one. Mute back your mic, please. Mute back your mic. Mute back your mic, please. All right. So a bearings question here, 2021. And that's in recent times, once they give a bearings question, they tend to give a diagram and give us so much information. They are a lot easier than they used to be in the past. All right? All right, Mr. Merchant? All right, good. This question says, from a harbor H, same harbor H again, the bearing of 2 ships Q and R to Q and R again are 0.69 degrees and 151 degrees. So it's a question very similar in the same year. It says, and that's a reason why you guys need to do 2024 January paper. I know that in the same year, a lot of the time the question come a kind of similar kind of way, right? All right. So the question says the bearing from H, and they show the, again, see, they show this one for you, but they don't show this one. They don't show the 151. They don't show this one. If we were to show this one, remember now, both of them are from H. So from H to R, where R is down here, and this is a from, that angle will be all of this. That will be 151 degrees. Clockwise from the north line at the from position. That angle is 151 degrees. All right? So be mindful of that. Then it says Q is 175 from 8. Again, they didn't show this distance. That's this distance over here. Mute your mic, please. Mute your mic. Mute your mic, please. All right. 171. So this distance is 171. We're going to put down afterwards. And they give us this distance, 242. They give us that one. So they give us some of the information. And we have to fill in the rest, right? It says complete the diagram to show the information given. All right. So we're basically going to put in information that was not given. So this distance we said is 175. This distance, 175. Let's put it down there. 175. So this is 175 kilometers. And remember that this angle all the way around here, they didn't put that on either. That angle is 151 degrees. Let's put it out here so it's not in the way. And so we can calculate the angle between those two sides inside here. That angle inside there becomes the difference between 151 and 69. But I can agree to that. What that work out to? 151 degrees minus 69 degrees. What that work out to? Somebody tell me. How much? 82 degrees. I'm doing the calculation here now. I'm going to show it in there, right? But I can leave the calculation out here on my paper so the examiner see what I did. So this is how I get my 82 degrees in here. This angle is important for me to get because it now allows me to use the cosine rule, two sides, and the angle between them to find the side over here. So it's almost like the same thing again, right? Let's see. It says calculate QR, the distance between the two ships to the nearest kilometer. This term to the nearest kilometer means that you don't put a decimal point. You don't put a value after the decimal point. You run it after the nearest whole number. That's what it means. All right? So it's the same thing again, guys. So you see the questions are basic repeated, and that's why nobody should have a problem with bearing questions in the exam. Because they typically asking the same thing all the time with different values, different angles, different distances. But they keep asking the same things. Every now and then, I might put a little bit something different on one of them. But if you understand it, then it's not a problem. Right? But for the most part, they're asking the same thing all the time. All right? So I want to use cosine rule again. Let's write it up here. Cosine rule again to find this side. Again, cosine rule has to be used, right? So let's write it. Cosine rule. Treat this like a hypotenuse. And this is like a two sides, and treat this like a hypotenuse. Start out that way. So it's going to be that the QR, again, is the square root of the 175 squared plus the 242 squared. It starts like Pythagoras' theorem, but it is not. You have to subtract a piece. That's what the cosine rule is about. Subtracting a piece. You subtract twice the 175 times the 242 times the cosine of the 82 degrees between them. That is the cosine rule. So I'm going to take all of this now and put it in its place down here on the paper. And just like the ones before, you do one calculation with this to get your QR. You don't need a lot of calculations for this. All right. So again, it's going to be this. Mute your mic, please. Mute your mic. It's going to be the square root of 175 squared plus 242 squared. You're subtracting a piece. 2 times 175 times, what did I do there? 2 times, yes, the 175 times the 242 times the cos of 82. Now some calculator don't have to put the multiplication sign. You could just put the values in brackets, but sometimes it's just easier to put the times. That's giving me 278.2. But because the question said to the nearest kilometer, I'm just going to write 278. The nearest whole number, that's what this means. The nearest whole number is 278 kilometers. And remember, as you find it, you put it on the diagram. As you find the angle, as you find anything, put it on the diagram. So everything, you populate the diagram with information. So I'm going to put this distance on the diagram now. This distance, I'm putting it right here. So it's in front of me right here. So this distance is 278 kilometers. And again, it's the same thing. Going forward, I can use a sine rule because I know of this angle and side opposite each other. I know both of them. So going forward, I can use a sine rule. Again, the only thing we don't know in this triangle are these two angles. Any one of them we need to find, we're going to use a sine rule. More than likely, the next calculation, you'll need to find one of them. Chances are. But sometimes they ask something different. Let's see what they ask on this one. So find that distance. Next thing. All right. Remember, I spoke to you about this earlier. Look at this question. How far due south? Let's look at it carefully. How far, calculate how far due south. Due south means towards the south. How far due south is ship R off Harbor H? Off Harbor H simply means from H. And this due south means towards the south. That's just the language of the topic. So what is this distance asking about? How far is ship R south from H? Let's look at it. What distance is talking about? So is this the one from this number? The one how far south? So it's this vertical distance down here. The one till I put it in purple. They put talking about this vertical distance down here now. Down to this line, this east-west line. So they're talking about this distance. This is the distance that they want to know. That's how far due south R is from H. But I can appreciate that this distance they're asking us for. Get me? So to get that distance, we're going to come and work in this triangle, which is now a right angle triangle because this is an east-west line and this is a north-south line. So this angle right here is 90 degrees. And if that is the 90 degrees, the side opposite the 90 is now your hypotenuse. This is a hypotenuse. And we're trying to find this side. So we need either this angle or this angle. Now this one is easy to find because look, remember that all of this is 151. And you will complete 180 if you come out to here because this will be a straight line 180. So then this angle inside here that you want is 180 minus 151. But you see that? 180 minus 151 inside here. So inside here is 180 degrees minus 151 degrees inside here. That will help us to find this side. It's going to be the adjacent to this angle. What is work out to? 151 minus what says become what? 29?
29 degrees.
All right, thanks. So this angle is 29 degrees in here. 29 degrees. And you're working in this right angle triangle now. And in that right angle triangle, this is your hypotenuse. And the side that you want here is the adjacent. If the question was how far east R is from H, they were asking you for this distance right here. If it was how far east R is from H. But this time it was how far south R is from H. So they're asking us for this adjacent side. Let's mark it on the diagram, call it something. Let's call it X on the diagram so we can reference it. So we'll call this distance, I don't want X. What's this distance? I want to reference it. And because it's now a right angle triangle, we can now use so-called tower, the trig ratios. And we want the adjacent and we know the hypotenuse. Remember, it is so-called tower. You can use so-called tower when you're working in a right angle triangle. In this case, what are the sides involved? We want the adjacent. So adjacent is in the cos, adjacent is in the tan. We know the hypotenuse. Hypotenuse is in the cos, hypotenuse is in the sine. So two things involved in the cos. So I want to use cosine of the angle to get this one. I want to use cos. So let's set it up. The cos of the angle, which is 29 degrees, is equal to the adjacent side which you want, call it X, over the hypotenuse, which is the 242. To leave this X as a subject, we're going to take this 242 and just multiply it up here, cross multiply. And so the X, let's shift this up a little bit. So the X is going to be equal to 242 times the cos of 29 degrees. When you do this calculation, you get the distance that you want. I'm going to move this and put it down there now, where we need it. So let's put it, I just did the calculation there so that we can reference the diagram, right? In the exam, you have to do it down here. So we can say, if I'm in the exam room, I'm going to tell him that this distance that they asked me for, I'm calling it X on my diagram. I'm going to put this here to show that the X that they see on my diagram is what they're asking me for. So when I calculate the X, that's my answer. Calculate this now, and that's my answer. So it's 242 times the cosine of 29 degrees. All right, I'm going to give it again to the nearest kilometer. So it's going to be 212 kilometers. I'm going to give them that, 212 kilometers. I guess if you give them 211.7 or anything like that, they give it a mark. But generally speaking, if the question doesn't tell you the level of accuracy, as this one didn't, you'll give your answer to 3 significant figures. If answering a question that the answer is not exact, and the question did not tell you what level of accuracy you should give, you generally give your answer to 3 significant figures. In the case of degrees, you give it to 1 decimal place, yes? Let me turn it up. Why you're cold, but I'm hot. I'm very hot. Because I'm all the way up here from it. You all know that the AC is in the room, so you should bring a sweater every time. The sweater is always here, you know, like we just bring it here now. That's been here since September. It's always here. Just kind of use it, just tip the thing up like that. Just tip it up like that. All right, leave it there. All right, guys, everybody go to this one. But okay with this one? But online, okay?
Yeah.
All right, beautiful. All right, let's see if there's anything else on this question. Or question done, that's it. All right, so this one didn't ask us back for a bearing. What time is it now? 5:30. Remember, we're going till 9 o'clock. What time is that? For one hour so far, right? All right. More maths equal better math. Let's do another one. Let's do January 2020. Huh? Break. Want a break after hour and a half? Come on, not joke, man. But there's the 2 questions I want break already. 2 questions. You know what, man? I think we're not good. That's a problem. Let's go on one more. Let's do January 2020, COVID year. January 2020. Huh? Feel like what? No, they didn't. All right. All right. January 2020. Let's go. Now, what I'll do, if people inside here want to take a break, but the people online want to continue because they don't feel so no good, then I'll work with the people online and you all can go. All right. Ready again. Hey, relax. Ready again. Let's go. Ready again. Let's go. Here's another one. 2020. All right, relax again, guys. Relax again. Business time. This question said, diagram below not drawn to scale shows the route of a ship cruising from Palm City. I'm not interested in that. I'm interested in that it is from P to Quayton. I'm not interested in that. It is Q. So this is from P to Q. That's what is relevant. And then it went on to R. It said the bearing of Q from P is 133 degrees. So this is from P to Q. With the help to, they showed it here. From P down to Q is 133. So they're helping you. They're putting some of this information on the diagram for you. All right? It says, and the angle PQR is 56 degrees. That's right here. So the information that they have given you up here is all on the diagram. They have even given you these 2 distances that they did not mention in the diagram. We have to work with the diagram. So far, the diagram is populated for you. It says, calculate the value of angle W. That is right here. Calculate that angle. So they want us to basically now look for the Z angles and the U angles and so on to get this angle, right? Let's look at it. Let's break it up. Multiple ways to do this. Now remember, these 2 angles are what we call co-interior angles. We simply call them U angles because they appear to be angles in this U. We have these 2 parallel lines and you join them with this transversal line here. Then it's like they are in a U. And so these 2 angles, we call them U angles. They are supplementary. So the 2 of them add up to 180 degrees. And so since the one up the top is 133, where's the erase button? Then this one inside here is 180 minus 133. Let's put it over here. 180 degrees minus 133 degrees. I'm going to show them how I get this angle, which I'm going to put on the diagram. What that one work out to?
47 degrees.
Somebody tell me. Thank you very much. 47 degrees. So this angle inside is 47. Put it on the diagram. 47 degrees. And they were nice because we know that total angle on a straight line through a point is 180. And so this angle down here is going to be 180 minus the sum of these 2. But good at that? Good. So we can show that calculation here. I would have to put on the
77.
77. All right, so somebody is preempting. Good. So the omega, the W, is 180 minus the 47 and the 56. I don't have to put on the degree, and so it is 77. So the W is 77, but the angle is 77 degrees. So if we can ask for the value of W, it is just 77. That's for the angle, it is 77 degrees. So since I say angle W, I'm going to write the 77 degrees. So let's write it. Angle W, or W degrees, is 77 degrees. W degrees is 77 degrees. That is it. And I'm leaving the calculation there. All right, beautiful. Next question. Determine the bearing of P from Q. Let's be careful with this now. It is from Q to P. So the bearing must be placed at the from position. Remember, from Q to P. And you have to show that bearing angle that you want on the diagram. From Q to P. All right, let's look at it now. So one from here to up here. So the angle that we want from here to here, this is an outline at the from position. It is a clockwise angle from that line all the way around to there. But I can see that? Nice and easy. All right? It's relatively easy because this part of it is 180 degrees, and then you add in these two, the W and the 56, to get the total bearing that you want. But I go with that? All right, let's mark it now. So we're going to mark it on the diagram and call it theta. I can just tell him it's all of this, right? But see that is 180 plus the W plus the 56. Everybody can see that? Online, everybody can see that?
Yes, sir. Yes, sir.
Yes.
Good.
Yes, sir.
Right.
Yes, sir.
I could have been, or it could have been 360 minus the 47. Same thing, right? 360 minus the 47. Could have been that as well. 360 minus 47. Maybe that's the easier way actually. 360 minus 47. Let's do it that way. 360 minus 47. So it's going to be 360 degrees minus 47 degrees. What is work out? Somebody tell me what that is. 313 degrees. That is it. All right. Next question. The distance P, distance RP. The distance RP. That's this one. This again is cosine rule because you have two sides and an angle between them. Cosine rule again give you that one. So it's the same thing all the time, guys. It's like they don't know what else to set. Let's do it over here. Cosine rule again. So this side PR, start like Pythagoras' theorem, you don't need no formula. Is a square root of this side squared plus this side squared. 210 squared plus 290 squared. Then you subtract a piece. You subtract twice the 210 times the 290 times the cosine of the angle between them, which is a 56. And you square root in all of that. Let me shift it down. Somebody's at the door. Let me shift it down. Somebody's at the door. Somebody open the door for me and see who that is. Evening. I'm in class. I'm in class. All right. That is it. So I'm going to shift this down. I think you had a football match, I think. Over there? All right, one. You told me that you had a football match. Okay, it's here. All right. So shift this down here. Mute your mic, please. Mute your mic, please. All right. So this is the same calculation, guys. What you get? How much? Somebody work it out already? 245 kilometers. Somebody else check it for me, please. Just make sure consistent. 245 kilometers. Put it on the diagram. Somebody's got the same thing?
Yes, sir.
Somebody else did this calculation? All right, good. 245. Let's put on the diagram. So this side is now 245. All right. And then now, next thing, the other question done. Easy question, done. That's it. All right, what? Break now, I'll do another one. All right. All right. All right, I'm going to do one that has some elevation in it. All right. 2024, January this year. That's some elevation built into it. All right. January this year. All right, let's do that one. All right, so this is this year exam, January this year. So you see the trend, questions that come on January, a lot of the times the question in June kind of similar, right? So there's one thing you want to do, make sure you fully understand the one that they set in January. Don't make no sense to set one in January and set back something. And then, you know, it's similar and you can't do it. That don't make no sense. All right, some person is requesting to record. No problem if you want to record it. I'm here to help. All right. All right, this is the diagram from that year. And you see there are 3 triangles in this one. All right, 1 year, 1 year, 1 year. There's actually 4 triangles because then there's this big one out here as well. All right, but no problem. None of them are right angled. So in each of them, you have to use sine rule, cosine rule. All right? Let's see what it says. It says E, F, G, and H are 4 points on level ground. That's what bearing is about, looking around from left to right. In fact, bearing is about facing north first and then turning to the right. So bearing angles are always horizontal, parallel to the ground. These are points on the ground. He said the diagram below gives information on the distances and angles between the points. So they don't bother say anything up here. They're telling you to go to the diagram for everything that you want. So you can see, for example, this angle here is 54. This side is 5.3. This is 6.9. This is 11. First question is for us to show that the angle inside here is 29 degrees. Let's look at this triangle right now. This triangle. They're asking us to find that angle inside that triangle. In this triangle, we know the 3 sides, but we don't know any angle. It is not rocket science, guys. Once you're given a triangle that is not a right angle triangle, where you know 3 sides, but you don't know any angle, you have to use the cosine rule to find one of the angles. You have to use the cosine rule to find one of the angles. And then you have to transpose to find that angle. This is an example of that situation. Once you get a triangle that is not a right angle triangle, where you know 3 sides, but you don't know any angle, you have to use the cosine rule to find one of the angles. And then you have to set it up the right way if you're going to use it in the cosine rule. All right, so look, we're going to set it up now. Pay attention. Remember, the cosine rule is a thing where you're working with 2 sides and an angle between. Good? So you need to identify your 2 sides with that angle between to set up the cosine rule. And then now it's almost like the side over here becomes the hypotenuse. That's how the cosine rule set up. So since this is an angle, this side over here will act like a hypotenuse in the cosine rule. Come remember now, start out cosine rule like you have an hypotenuse in there, and they will subtract a piece. So working these two now as your angle and side opposite. So you have to set them up, you have to set it up the right way. So this is what will start the cosine rule, and this is the cosine of an angle at the end of your cosine rule. So you have to set it up the right way. All right, let's go now. So it's as if you're saying these are your two sides and your angle between. And like you're trying to find, it's almost like you're trying to use the cosine rule to find this side. But it's just that we know the side. It's just that we know it. So still you don't need to write no formula. Just a matter of placing the values the right place in the cosine rule. Start out like cosine rule and subtract a piece. So let's go. But the only thing with this time now, we're not going to square it. We're not going to square root. We're not going to square root. We're going to start like Pythagoras theorem with the squares on it and everything. Because remember, it's the angle that we're trying to find this time, not a side. So ready, let's go. So cosine rule. We're using the cosine rule again to find that angle. Cosine rule. So start out. This would have been the opposite side if you were doing the cosine rule fully, right? So it is 6.9. This time we're going to put a square on it. We're not going to put a square over here this time, because we're trying to find the x out here. That is equal to this side squared plus that side squared, as if it was Pythagoras' theorem. 5.3 squared plus 11 squared. As if it was Pythagoras' theorem, as if this was an hypotenuse. But the problem is this angle is not 90, so it's not an hypotenuse. So you have to subtract a piece. It's the same thing as subtract all the time. Twice the product of these two sides, the 5.3 and the 11, times the cosine of the angle between them. Now between them is x. You don't know the angle, it is x. And like you have this now and you're transposing to find the x. That's what this question is all about. Easy. And listen, don't bother waste time where you work out this and work out that and work out that. You're going to bring everything down to one expression. Transpose and make x a subject and bring everything down to one expression. You just need to do this with one question, and any question you're doing with three sides, and you have to use the cosine to find an angle, is the same steps all the time. Just that the value is going to be different. All right, watch it now. First thing I'm going to do, no space we have. I'm going to take this, because it is negative over here. I'm going to transpose all of it over onto this side. I'm going to take this 6.9 squared and transpose it over this side and subtract it. That's my first step. Look what I'm going to get when I do that. All of this coming over this side is a positive. 2 times 5.3 times 11 times the cos of x equals, this stays on that side, which is the 5.3 squared and the 11 squared. And then this now come over this side and subtract. Minus 6.9 squared. But I can see that so far. Then to leave this as a subject, I need to take all of this and divide it on this side. It's as if I'm dividing both sides by this expression. But the shortcut is to say you take all of this and divide it under here. I'm actually going to do it on the screen. I'm going to say I'm dividing over here with all of this divided under here. Let's do it. I'm going to take this and divide it under here. Better good at that? Better good at that?
Yes, sir.
That's what's gonna good. All right? And then now, since you have cos of an angle, since you know cos of an angle equals this thing, it means that the angle becomes cos to the minus 1 of all of that. Good? That's what happens. So let me write let me write that line. So the x becomes cos to the minus 1 of all of this. Since me have a tablet, me just copy it down instead of write it again. Let me just copy it. Everybody good at that? Online, everybody good at that?
Yes, sir.
Good. And then no, it's a matter of just putting this in a calculator. I say, when you do your calculation, guys, you try to use a calculator one time. There's no need to work out this and work out that and work out this and work out that. Waste of time. Simplify the expression, transpose. So you just put one calculation in the calculator. Generally speaking, when you're doing the mathematics, you must use a calculator one time to get your answer.
Sir, if you
Yes.
use it one time and you put all of this in the calculator, for some people, the calculator might say error or give it a different answer from what you have.
All right, and that is why you need to get a proper calculator. You need to get one of the calculators that you can type this in exactly as it appears there. Not something like it. You want to type this in the calculator, and when you look at it, it is exactly like it appears there. That's what we call a textbook display calculator. Get one of those. If you're serious about getting success in this exam, you get yourself one of those calculators. Arm yourself with what will give you the correct answer. Get a calculator that you can type this in and it appears exactly like that. What the calculator name again? Casio ClassWiz. ClassWiz. Casio ClassWiz. Somebody tell me one that works. Huh? Somebody tell me one that works. Let me say. ClassWiz. Casio ClassWiz. What that one name? No, bring it come. Let me just say it. Let me say it here. What is one name? Casio. Get this calculator. Casio FX 82 ES Plus. Go to the store and buy one of that calculator. Or you can buy the Casio. Stop talking. Hey, stop talking. Casio FX 115 ES Plus. That one will do it as well. Bring the ClassWiz, come. Where's the ClassWiz? Come with the ClassWiz. This is the boss one now. This is the boss one. This is the one this is my favorite. Use this one all the way up to university and back. Casio.
Put them out.
FX. Oh, put it back. Let me put it back. Hold on. Let me put it back. Those two, get one of those two, or you can get my favorite, Casio. This is one that I get for my daughter. Casio FX 991 EX. See the keyword here now. ClassWiz.
No.
Get this calculator. If you can't get that one, get any one of these. And you're good to go. Try get that one first. Yes?
What happened to Casio FX 300 ES Plus?
I don't know all of them, you know. If it can type this and show it like how it stay here, so I'm good with it. Can it show that exactly as it appears there? That is the question I want to answer for me. Can it show this exactly as it appears here on the paper right now? That is what you want to get. You don't want the one that's going to show 5.3 slash plus and all them things there. No, you want to look like this, look like maths when you type it in there. I don't want the one that show the thing like when showing a fraction, it do 5.3 and one little symbol something so 6. I don't want that.
It type
No,
like
that's
that.
not good enough. Huh?
It type like that, but how do you get
Dash away that one. Throw away that one.
No, it says 5.3, just like how it's there, and then you have the division sign at the end. That's how it's gonna show.
You mean like 5.3 and then divided?
Yeah, after I finish, then I have to press the division sign to get it.
Then a
under.
lot of people, look here, a lot of people gonna get a problem because it's when after they put the division sign, they're gonna put 2 times 5.3 times 11 and it's gonna be wrong. If you're using that one, you're gonna have to know that you have to bracket all of this after the division sign. Or you have to know that you're dividing by 2, you're dividing by 5.3, and you're also dividing by 11. Why go through all of that when you can just get a calculator for a little bit of money that you can type this exactly as it is and you don't have to worry about whether you enter it in the calculator the right way or not. Just do me tell you, please. Just get the calculator. Students in my class, when them get the wrong calculator, I take them calculator, I throw it outside. It's not the right calculator. I take them calculator and I throw it away if they don't have the right one. Because I wanted to get the right answer. It don't make no sense you have the right expression and then get the wrong answer. And if you don't know the proper way to enter this in the calculator, you will come up with the wrong answer and get error messages and all these things. I'm telling you. So to avoid all of that, you just get a good calculator. Get one of these 3. They are selling in the stores. All right, especially if you intend to do math at a higher level. You want to add maths, you want the pure maths, you want the applied maths, you want the university level maths. Just get a good calculator from now. All right, and the ClassWiz will carry you all the way through. ClassWiz. All right, enough of that. So let me show you a calculator. I'm going to show you when you type it now. When you type it in the calculator, right? When you type it in the calculator, you want it to look like this. Look at my calculator screen now. Look. I'm going to put cos to the minus 1. Some calculators put cos to the minus 1 and they show you arc cos. I don't want that. I want to see cos to the minus 1. Then I'm going to put a fraction. I want to see my fraction. The top and the bottom of the fraction. I put in 5.3 squared. Some character put one little thing like this for the square. Like so. Don't want that foolishness. Plus 11 squared minus 6.9 squared all over 2 times 5.3 times 11 on the denominator. See the 29.5 up here? Now, some people with their full calculator are not going to get it because they can't enter that the right way. And you run into problems. Come on, man. It's just a little bit of money for that. Let's do that. Use the money that you don't pay for another marathon that you're not paying for this one and buy it. All right? Just do that for yourself. So this is what they said, 29.5. See there, 29.5. 29.5 degrees shown. All right. That is it. Okay. Next question. All right. So this is the part I'll tell you about. It says a vertical tower, GT, is constructed at the point G and is pivoted to the ground at E, F, and H. So it's like you have the point G, and then put a vertical thing at G, and the top of it is T, and then you have all these other points on the ground. And these places are on the ground. But then now from this vertical thing, they are now using wires to support that vertical pole. Then put this one slant. Then put this one slanted so you can see it. Put this one like so. And like they're using wires to support this thing. And everything, the blue lines here are on the ground. And this is a vertical thing. So this angle is 90 degrees, because that is vertical and that is horizontal. And this angle between here and here is also 90 degrees, because again, this is vertical and this is horizontal. And then again, this is vertical and this is horizontal. So again, this angle is 90 degrees. So this angle is 90 degrees. And let me remove this one. This one is also 90 degrees down here. Between here and here is 90 degrees. So the three-dimensional situation you have. And you have the vertical pole. Well, let's go back on the diagram now. So I'm just trying to explain the situation that this question is talking about. So let's say it again. The vertical pole is at G, right? So let's look at it. The vertical pole is at G right here in the middle. And from it's like T is at the top of this G. You can't see it because this is like you're in the sky. This diagram is like you're in the sky looking down. So the top of the pole is right here. The top of the pole T is right on top here, on top the G. The T is on top the G if you're looking down. But if I were to draw it from the side, if I were to draw this diagram, this situation from the side, let me see which are the points that they want us to think. They want us to talk about, they said the angle of elevation of the top of the tower from F is 31 degrees. So it's going from F to T, top of the top of that tower. All right, from F to T. Let's see. So this is F right here. So we're talking about from here to here, but the pole is here. So I'm going to draw the situation over here. So like you have this point G on the ground, and you have a vertical tower there. This is a vertical tower at G. And the top of it is T. And you have this line out here to T. I'm going to draw it like this. Or to F, sorry. F. And this is a vertical thing that they just told us about. And this distance, the same distance there. This distance is the same 6.9. So this distance is 6.9 meters. And they're telling us that the angle of elevation from here to up here is 31 degrees, I say? 31 degrees. So it's like you're on the ground here and you have to elevate the line of sight. Oh, it's a wire. No, the wire is 31 degrees, right? Angle of elevation is 31 degrees from F to the T, right? So this is it. That line represents the line of sight, but that's like the wire from the top of this pole or this tower down to F. That wire makes an angle of elevation from the horizontal upwards of 31 degrees. So the angle looking up here is 31 degrees. Now this T is actually right on top of the G, you know. So your vertical pole is right here at the G, but because you're looking down at this diagram from the sky, you're not seeing it, right? You're not seeing it. Can you all imagine this situation, guys? Right along here, and the T is on top of the pole, the tower right here. But I can say that. You have to be able to see these three dimensions, you know. So we have a right angle triangle here now because this is vertical pole and this is horizontal ground, or vertical to horizontal ground. So this is 90 degrees. That's a right angle triangle. So we can do so-called to that triangle. So let me move this diagram down now on the next page. So this is the situation that they just described for us. I've shown it like an elevation view. And the question is asking us now, It says, what is the length of the wire that secures T to F? So they're asking us for the length of this red wire here. That's what the question asking us for now. In this diagram, that's the hypotenuse they're asking us for. I'm going to do it in red. Since we want to find that red length, I'm going to do it in red. So it's hypotenuse. So because the right angle triangle is so-called tower. So we know the adjacent to the angle, and we're trying to find the hypotenuse. So adjacent and hypotenuse, that's cos we're going to use again. So-called tower, we're going to use cos of the angle. So it's going to be that the cos of the 31 degrees equals the adjacent side of 6.9 over the hypotenuse TF that we're trying to find. TF. So trying to find the TF. So to make the TF a subject, it's quite easy. We're going to take the TF and multiply it up here, and then take the cos 31 and divide it under here to make the TF become the subject. Cross multiply and divide. All right? So then we'll multiply with TF. We're going to get the TF up here equals the 6.9 remains. Cos of 31 is divided under. So it's coming under here now. So divide this by the cos of 31 degrees. This calculation is going to give you the TF. It's going to be in meters. Huh? You see what? What's that? 8 or 8 exact. 6.9 over the cos of 31. So tell me exact 8. They're not exact 8. Give your answer to 3 digits if they don't tell you. See? What is the length of the wire? Don't say 8. Give your answer correct to 3 significant figures if they don't tell you the accuracy that they want. Right? 8.05 meters, please. 8.05 meters. Don't put 8. If you put 8, they're going to give you the marks here, but it's still, you still need to have good practice with these things. Give your answer to 3 significant figures. If they don't tell you how accurate, you must give your answer. And it is not exact. Everybody okay with this calculation? Online, everybody good?
Yeah.
Everybody good? All right, good. Next part now says, all right, some bearings are asking us for now. It says, the bearing of E from H, let's mark that properly. The bearing of E from H is from H to E. They're telling us that it is 228. Let's put on the diagram first. From H to E. From H to E. So see H here, see E here. So it's from here down to here. So here's the H. This is the north line. It is this angle that they're telling us is 288 degrees. Good? That angle is 288. All right. So this, all of this angle here is 288 degrees. Now remember that inside here is the X, which you know already is 29, don't it? 29.5, we did that. The X is 29.5. And right here is 54. So if we wanted this angle right here, we just need to subtract those two, right? But that is the angle that they gave us in the question a while ago, the information. All right, we'll put on the diagram. They want us to find the bearing from E to H. Let's mark it from E to H. So the bearing is that from E to H. Let's look at that angle that I want. From E to H. Let's see what angle that is. So from here up to there. Which angle is that? Let's look at it. This is the north line at the front position. This becomes the front position in the one from here to there. So this is the north line at this front position. Let's do this one in blue. This is the north line at this front position. The angle that they want is this one. That's the bearing angle they want. Clockwise from your north line. That question is asking us for that diagram, for that angle. Now that angle can be found easily because remember it is a co-interior with this one, right? because that's another dot line. These two angles add up to 180. And we can find this one. It is 360 minus the 288, right? Because total angle around this point is 360. Up to here is 288. So inside here is 360 minus 288. Let's write it.
72.
How much I get? 72. It is 360 minus the 288. That's what this angle is. And then these two add up to 180 because they are co-interior. They are like angles in this U. And so this angle that I want down here now becomes 180 minus the 72. 180 minus 72. Let's write it. 180 degrees minus the 72 degrees. What I work out to? 108 degrees. I want to put this calculation down here. I'm leaving these on my diagram as my answer. And I'm going to write the 108 degrees down here. So because I showed it on my calculator on the diagram, I can write the 108 down here. Because how I got the 108 is shown on my diagram up here. I'm just going to leave it like that on my diagram. Next bearing angle that I want is the bearing from H to G now. Let's make note. Now this marking that I'm doing, you don't have to do it. I'm just doing it for good practice. To see that you must note the from position. So I'm doing again from H to G. So the bearing has to be measured at H. All right? From H to G. Let's see what that angle is on the diagram. From H to G. See H here, so. See G right here, so. Let's show that angle now in purple. From here to here. This is the north line at the from position H. We're talking about now this angle. Yes?
You made an error. The 288 should be 228.
It's 228 in the question?
Yes.
Let me see. Oh, thanks for that. 228. All right, let's correct up there. It's not 288, guys. It's 228. All right, let's recalculate these things. So this is 228. 228 degrees. All right, write this out again for me there. What is work out to? 228.
132.
Hold on. 288. 228. So this becomes 132. So this becomes 132. Should have known because the angle look like 108 at all. Should have known. And they were subtracting. Sure, subtracting the 1. Subtracting the 132 now. I will get what is work out to now. .48 degrees is the bearing angle. So I'll put the 0 in front of it. 0.48. Thanks for that correction. So this is 48 degrees. So I have to put 0.48 degrees as shown on the diagram. All right? All right, let's do this one right now. So from H to G. From H to G. Let's do that one in purple on this diagram. So we're talking about now. This is the from position H. This is G. So you want the bearing out to here. From here. So it becomes the clockwise angle. Let's draw it. The clockwise angle to here. This is the angle that we want now. This purple angle is the angle that we want. All right. We're going to get that angle now. Huh? What? All right. So the whole of this is 228. All of this is 228. I will subtract the 54 to get it, right? So this purple angle, because everything out here is 228, which is inclusive of this 54. So this purple angle that we want, which is the bearing angle, is the 228 minus the 54. So this angle that I want is 228 minus the 54 out here. What that work out to? 174 degrees. But I can say that. But I go to that. 174. So I'm leaving this on my calculator and my diagram again as part of my answer. And so I'm just going to write that angle 174. So it's 174 degrees. And I see some 1 marks question, so they're easy. That finishes that question. All right, it's now 6:15. We're going to break until 6:30. And then we'll come back and we're going to do circuit theory. All right, we're breaking for 15 minutes, guys. We're going to come back and do some circuit theory. Circuit theory. 15 minutes break. All right, guys, ready now? Online again. All right, so we're gonna look at some circuit theory now, everybody. Another almost short topic, circuit theory. One of those topics that's very, very popular on the exam paper. Right? What some persons tell me is that oftentimes they know the rules, but they don't know what rule to use to identify the angle. All right, so we're gonna take a couple minutes just to recap the rules. Mute the mic, please. Mute the mic online. Mute the mic. We're gonna take a couple minutes to recap the rules. There are 7 main rules, and then I'm gonna look at a process that we can use to decide which rule we're using or which rule is applicable to finding an angle. And then we're going to do some examples. All right? So what are the 7 rules? The first rule is what I simply call the center rule. For simplicity, we just call it the center rule. It says the angle at the center is twice the angle of the circumference when they are subtended by the same chord or subtended by the same arc. So if I have a circle and this is the center of the circle and there's an angle subtended at the center, right here, this is the center. If this angle is, say, 70 degrees, then this is a chord that is subtended the angle, or the angle is subtended by an arc. This would be the arc that is subtending that angle. All right, it's better. So again, let's say that this angle is 70 degrees. Again, I'm saying either this chord is subtending the angle or this arc is subtending the angle. The rule is basically saying that the angle at the center is twice the angle of the circumference. And so if the same chord or the same arc subtends an angle at the circumference, or subtending an angle from these 2 points on the circumference up to here, for example, then the angle at the circumference is half this one, and this one will be 35 degrees. The one at the center is twice the one at the circumference. That's the first rule, call it the center rule. Angle at center is twice the angle of circumference where they are subtended by the same chord or the same arc. So it could be that this is a chord that is subtending those 2 angles, or this arc is subtending those 2 angles. The one at the center here is twice the one at the circumference. Call it center rule. The second one, we call it the same segment rule. Same segment rule. That's how we just simply call it. For simplicity, we say it's the same segment rule. It basically says angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. So again, if I have a circle and I have an angle subtending from here and here at the circumference there, then that angle here is subtended by this chord, or we can say it is subtended by this arc. That's this angle. Let's say that angle is 30 degrees again, just for example. If this same chord or this same arc between these 2 points go on a different color and subtend another angle circumference in the same segment, then this angle is also 30 degrees. Why do we say same segment? Because if I were to put a chord across here, then this would be the minor segment, and over here would be the major segment. These two angles, they are in the major segment, and they are subtended by the same chord, or they are subtended by this same arc. So they are equal. Angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. That's the same segment rule. The third one, that's number 3. And they are not in any particular order. I'm just going by how I remember them in my head. 1 and 2. Oh, I should have maybe done the diameter rule. Let's do the diameter rule next. There's another rule that I call the diameter rule. Diameter rule.
By chance, can you go through the other one, please?
Which one? I'm gonna do
The
all.
one before. The one
I'm gonna do
before.
all. What do you mean go through it? Let's go through it. I mean
Like, go back over it.
this one.
Yes.
Say it again. All right. It's called a same segment rule. It's angles in the same segment that are subtended by the same arc or subtended by the same chord. They are equal. Once they are subtended by the same chord or by the same arc, then they are equal. So if I'm going to form an angle from these 2 points on the circumference of the circle, from these 2 points, I'm going to form an angle at the circumference over here, like this. So this angle is subtended by either this arc, an arc can subtend an angle, or a chord can subtend an angle. So that angle up here right now is subtended by either this arc or this straight line chord. If this angle up here, give it another angle this time, is 25 degrees, subtended by this chord or subtended by this arc from these 2 points on the circumference. And I'm going to use that same chord or that same arc to subtend another angle at the circumference again, and the 2 angles are in the same segment, then they are equal. So if this one is 25, then automatically this one is 25. For the simple reason that they are both subtended by this chord, or I can say they are both subtended by this arc, and they are in the same segment. Why do we say same segment? Because a chord divides a circle into 2 segments. This one under here is the minor segment that I've shaded. Over on this side, up to the chord, is the major segment. These 2 angles, they are both in the major segment, and they are both subtended by that same chord or this same arc, and so they are equal. Simple as that. Any number, if I even draw another one here, from these 2 points again, and put another one in between them, like this, then this angle also is 25 degrees, right here. It's 25 degrees again. Why? Because it is subtended by the same chord or subtended by the same arc, and they're all in the same segment. Angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. Good now? Okay, online?
Yes, sir.
All right. Then we come to the diameter rule, which is the easy one. Angle subtended by a diameter is 90 degrees. So if I have a circle and I have a diameter, let's say a diameter, remember, diameter must pass through the center of the circle. Once that diameter subtends an angle at the circumference, that angle is 90 degrees. So if I draw a line from here to here, and then draw here, so this diameter is now subtending this angle at the circumference. This angle must be 90 degrees. Angle subtended by a diameter is 90 degrees. Another way of saying this one is that angle in a semicircle is 90 degrees. Because what they're basically saying is that this now, that is in red, is half of a circle. It's a semicircle. And the angle in it is 90 degrees because it is subtended by the diameter. But they don't tend to give you semicircles. They tend to give you circles with diameters subtending angles. So we prefer to say angle subtended by a diameter is 90 degrees. Remember, I know the diameter must pass through the center of the circle for it to be a diameter. So even if you have a line close to the diameter subtending an angle, it is not 90 degrees. The diameter is a line that must pass through the center. And once a line passes through the center from circumference to circumference and then subtends an angle at the circumference, that angle is 90 degrees. Angle subtended by a diameter is 90 degrees. We call it the diameter rule. Angle subtended by a diameter is 90 degrees. I'm going to put up a chart afterwards so you can screenshot it with all these rules. That's number 3. So the center rule, same segment rule, diameter rule. 3 of them so far. The next one I'm going to bring up is one that we call tangent and radius rule. Number 4. Tangent and radius rule. That's how we just simply call it that in this class. Angle between a tangent and a radius is 90 degrees at the point of tangency. So if I have a circle and I have a tangent to the circle, remember the tangent touches the circle at a single point only. And then I have a line from that point of tangency to the center of the circle, that's a radius. So this is a tangent and this is a radius. The angle between them is 90 degrees at the point of contact, at the point of tangency. This is a tangent and this is your radius. Angle between a tangent and a radius is 90 degrees at the point of contact. We call it the tangent and radius rule. That one easy. Remember, if the radius extends out to a diameter like this, then the same thing. Angle between the tangent and the diameter becomes 90 degrees. That's what we call the tangent and radius rule. So this one now allows us to introduce what we call now the 2 tangents rule. 2 tangents rule. 2 tangents rule. And this is when you have 2 tangents from a single external point. 2 tangents drawn to a circle from a single external point. Let's look at it. If I have a circle here, and I have a point out here that I'm going to draw 2 tangents, draw tangents to this circle, I can only draw 2. So only 2 tangents can be drawn to a circle from an external point. I can put one of them up here and put the other one down here. Those 2 tangents. Those 2 tangents are going to be equal in length. That's the first thing to know. They are equal in length. And so if I join these 2 points of contact with a chord, a straight line, like this, then that becomes an isosceles triangle. That triangle with the 2 tangents and this chord is isosceles because the two tangents will always be equal in length once they are drawn from a single external point. Then one additional thing, the two tangents, if I were to draw a radius from this point of contact to the center of the circle here, and draw another one from this point of contact to the same center here, then what happens, remember that the angle between the tangent here and the radius here is 90 degrees. This is 90 degrees right here. Similarly, over here is 90 degrees. Over here is also 90 degrees. So right now, these two angles, they add up to 180 degrees, 90 and 90, 180. But these two tangents, together with these two radii connecting to the center, is a quadrilateral. The total angle in any quadrilateral is 360. If these two already add up to 180, then these two, this one and this one out here, also must always add up to 180 degrees. So once you know the angle here between the two tangents, then the angle between the two radii at the center, which is formed in that quadrilateral, they're going to add up to 180 degrees. And so we have a special situation here now, where because the opposite angles in this quadrilateral that is formed with the two tangents and the two radii, the opposite angles are supplementary. They add up to 180 degrees. Those two add up to 180, and these two add up to 180 as well. Then it means that this quadrilateral, which is formed with the two tangents and the two radii, is cyclic. It's what we call a cyclic quadrilateral. Not because the vertices are on the circumference, but because the opposite angles are supplementary. Right? So this is what we call a cyclic quadrilateral. The two tangents together with the two radii is a cyclic quadrilateral. It's a cyclic quadrilateral. And in a cyclic quadrilateral, the opposite angles, this means angles, are supplementary. And supplementary is just a fancy word to say they add to 180 degrees. So therefore, if the question tells you that the angle inside here between these two tangents is 40 degrees, then automatically the one over here is 140 degrees. Automatically. Inside here is 140 degrees. They must add up to 180, those two angles. So oftentimes when the question gives you two tangents, a lot of times they will give you this angle between them. And so if they ask for this one now between the two radii, you have to remember that they add up to 180. All right? That's that. Two tangents rule. They form a cyclic quadrilateral because the opposite sides add up to 180 degrees. All right. That's rule number 5. Then we come to the cyclic quadrilateral rule. Since we're talking about cyclic quadrilateral rule, cyclic quadrilateral, we can come to rule number 6, which is now the cyclic quadrilateral rule. Number 6. Remember, you know, this quadrilateral up here, you know, it is cyclic, you know, because the opposite angles are supplementary. That is why this one is cyclic. And 6, you will ask you that sometimes. Why is this cyclic? It is cyclic because the opposite angles are supplementary. But then you can have a cyclic quadrilateral again, in which you have a circle. If you have a circle, and you have a quadrilateral in the circle, I'm trying to draw a circle. And this quadrilateral in the circle, the 4 vertices are on the circumference. It's very important that the 4 vertices are on the circumference. So this quadrilateral, because the 4 vertices are on the circumference, it is also cyclic. And what happens here is that the opposite angles are supplementary. So these two angles across from each other, add up to 180. And these two angles across from each other add up to 180. And so if, for example, this angle is 50 degrees, then automatically the one across from it is 130 degrees. And these two also will add up to 180. Now, oftentimes, persons will get a diagram like this. Let me zoom it up for you. I made it smaller first. And believe that it is cyclic, and it is not. Let me show you a common mistake. Sometimes you get a diagram like this, and they have a quadrilateral inclusive of the center. Maybe like this, and like that, and like that, and like that. And this is a center. This one is not cyclic. It is not a cyclic quadrilateral because this vertex of the quadrilateral is not on the circumference. So this one is not cyclic. You cannot use the cyclic quadrilateral rule on this one. So you cannot now say that the opposite angles are supplementary. You cannot now say that for this one because this vertex is not on the circumference, but it's the common mistake that persons do. Some people get, for example, that this angle is 130 and they go up this one as 50, which is wrong. It is not cyclic. All right, so try not to get caught doing that. All right, then we'll come now to the last one, number 7, which is the tangent and chord rule. Some people call it the alternate segment rule, the same thing. Tangent and chord rule. How that one works. So like you have a circle, let's write it out. Tangent, tangent, and chord rule. So it's like you have a circle and you have a tangent out here, for example, that touches the circle at this point only. And then you might have a chord. You might have a chord. Let me draw the chord in blue as well. You might have a chord now from this point of contact out to here, for example. And so you have this angle out here, for example, between this chord and this tangent. The rule is basically saying that this chord that is making an angle of theta with this tangent, this chord itself is going to go and subtend the same angle theta at the circumference over in this segment of the circle. That's what I call the alternate segment. Because remember, I know this angle theta is actually in this segment. It's formed in this segment. And the other angle over here is in the alternate segment. So anywhere that this chord places an angle on the circumference over this segment is going to be equal to theta. The alternate segment rule, or they call it the tangent and chord rule. So it goes both ways. If I know this one, then I know that that one is the same. And if I know this one, then I know that that one is the same. I have to be able to know this rule going from inside here to out here, or from out here to inside there. That's a tangent and chord rule. This is a tangent out here, and this is a chord. And this is the angle between them. And the chord subtends that same angle at the circumference. And by the same segment rule, guys, if I were to use this chord and subtend even another angle up here, it is still equal to that angle theta, whatever theta is. tangent and chord rule. So far, so good, everybody?
Yeah.
So far, so good.
Yeah.
All right. So let me show you now a couple other things that we have to remember that becomes applicable in these questions. You cannot forget, well, one of the first one is the sector triangle, that it is isosceles. So remember now, if you have a circle and you have two radii drawn out to the circumference and you complete a triangle with a chord, then this angle is isosceles because this radius and this radius is the same length. So it means that this angle, whatever it is, and this angle, they are equal because the angles that are opposite the sides in an isosceles triangle are equal. In other words, the angle that is opposite to this side is equal to the angle that is opposite to this side. So these two angles will be equal. Simply because this is a radius and this is a radius. And remember, for an isosceles triangle, any one angle I know, I can find the other two. Any one angle I know in an isosceles triangle, I can find the other two because two of them equal. So if I don't know these two, but let's say I know that this one is, for example, 80 degrees. Let's say that this angle at the center here is 80 degrees. The total angle in that triangle is 180. So these two must add up to 100. Because the total in there is 180, you know. And if the two of them are going to be equal and add up to 100, then each of them must be 50. Similarly, if I work it the other way, where I know one of these two base angles now, let's say I know that this one is 50. Then because this triangle is isosceles, then you must know that this one over here is the same 50. And then because the total angle in there is 180, and these two add up to 100 already, then this one here must be 80. Because the total in there must be 180. So any one angle you know in an isosceles triangle, you're able to find the other two. All right. Remember also that in these questions, you can be given the situation with where you have to use Z angles, U angles, and so forth and so on. So if you have, for example, a circle and they put two parallel lines in there, like so, and these two lines are parallel, and then, for example, they might join them with a transversal line here from here to here. Then you have your Z angles. These are your Z angles. So this angle and this angle are going to be the same. So those apply in these diagrams as well. If instead, this line across here, if I put it here instead and join it this way to form a U, let's say I join them here. Then it means that these two angles now are co-interior. They add up to 180 degrees. So if this one is 100 degrees, then this one is 80 degrees. Co-interior. Once you have parallel lines, you have to look for your co-interior angles, which we call U angles. And you have to look for your Z angles. Another thing that is very important that you can look out for, I see them setting a lot of questions with these things recently, is this rule. Let me show you an example of it. Now the exterior angle of a triangle is the sum of the two opposite interior angles. The exterior angle of a triangle is the sum of the two opposite interior angles. So for example, you might have a situation where you get a circle like that, and you might have a line like this. And let's say you have another line like here. I'm trying to remember one. And let's say you have a line across here. like so. Yeah. Right? Let's say you have this in a circle, right? And let's say in this question, let's say you know this angle. Let's say that this angle is 30 degrees. And let's say that this one is 10 degrees. And they're now asking you for this one. Let's say they're asking you for this one theta. That angle theta is the exterior angle to that triangle. Let me show you. So if I complete this triangle with purple, I use the red to complete the triangle. If I complete this triangle with red, and I extend this side of the triangle out here, then you realize that this angle out here is really just an extension, is the external angle of the triangle, not extension, external angle. So there's a rule that says that the external angle of a triangle, or the exterior angle of a triangle, is equal to the sum of the two opposite interior angles. So this angle out here, this theta, is equal to the sum of this one and that one, because it is an exterior angle. So the theta would be equal to 30 degrees plus 10 degrees, which is 40 degrees. So that's another rule that is good to know. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. Now we could have found this another way, you know. I'm not saying that this is the only way, but sometimes I want to do the mathematics the quick way. So you could find this angle first by saying total angle of the triangle is 180. And because this is 30 and this is 10, then this one will be 140 because they add up to 180. Then you could go on to say total angle on the straight line is 180. And that's another way you could get that this angle then is 40 degrees. But a quick and easier way to do it is to recognize it as an exterior angle. All right? So that is just some stuff that we need to remember when we're going to do this circle theory question. But let me show you now what you consider, what is the approach to finding an angle. All right? Let me just give you a little brief of how you consider finding an angle. So let's say I have this circle, and the question is asking me for this angle up here. I'm just showing you the chain of thought, the thought process, how you approach it. Let's say the question is asking for that angle up there. All right? I always say to the students, you come back along the lines forming the angle until you reach the circumference. Come back along this side until you reach the circumference. Then you look now what is subtending that angle. Could be that it is a chord that is there. Then you look what else that chord is doing. So you find the chord that is subtending an angle, or it could have been you found the arc that is subtending an angle. Most times it's going to be a chord that you find. Then you're going to look what else that chord is doing. What is now? If this same chord that you found that is subtending that angle that you want, what are the possible things that it could be doing? It could be subtending an angle at the center. If it is subtending an angle at the center, then the angle at the center is twice. This angle inside here is twice. This will be 2 theta. Because the angle at the center is twice. What is another thing it could be doing? That's a center rule. This chord this angle that you want that is being subtended by this chord, what else could the chord be doing? It could be subtending another angle at the circumference. And if that angle up here is 20 degrees, for example, then it means that this angle is also 20 degrees, same segment rule. What else could the chord be doing? The chord here could be subtending an angle in the other segment of the circle here. It then means that this would now be a cyclic quadrilateral. because the chord that is subtending this angle is subtending another angle over in the other quadrant. So that becomes a cyclic quadrilateral. So these two angles now would add up to 180 degrees. And so you could use the cyclic quadrilateral rule. What else could the chord be doing? This chord that we have found that is subtending that angle, what else could it be doing? Could have been that it is making an angle with a tangent out here. And it could have been that they gave you this angle right here. You know this angle right here. So if you know this angle right here, then you know say the chord, because it is making an angle between the tangent and the chord, you know that the chord will be subtending the same angle. So if this angle out here is, for example, 30 degrees, then you know that this angle is also 30 degrees. Take on over this room. Over there. This room, yeah. Some of them in this room. Push up the door. Push up the door. All right. All right. What else could the chord be doing? Let's look at it. Let's look at it. What if the chord subtending this angle was in fact not a chord but a diameter? I want to make it a diameter this time. So if when I check it, I come back and it passes through the center of the circle, and the question asks me for this angle again up here. I come back along the angle and I find that is subtended from here, come back along this side, and I find that it's subtended from here, such that the item or the object that is subtending this angle is a diameter. Then we'll go for the diameter rule. Angle subtended by a diameter is 90 degrees. So I would know that this angle is 90 degrees. That's some of the typical chain of thought to find an angle. Find the chord and look what else the chord is doing. Find the chord and look what else the chord is doing. Look if it is subtending another angle in the same segment. Look if it is making an angle with a tangent. Look if it's making look if it is subtending an angle at the center. These things they look for. That is the approach that they can use. And so the only thing left for us to do now is a couple questions. All right, a couple questions. So those are the 7 rules, and I gave you a couple tips. Now we're gonna do a couple questions. All right, boom, bam. All right, so January 2024 has one end, and we just did that January 2024. So let me just pick it up quick. January 2024, right here. All right, let's find one on this. So where is it? This is one. All right, so that's a circle theory question. All right, question says K, L, M, and N are points on the circumference of a circle, center O. This is center O. It says XY is a tangent. So they give us this tangent out here at the point K, and it says angle LKY is 48 degrees. That's the angle over here. That is the angle between this chord and this tangent is 48. I know that there's a tangent and chord rule. Angle here is 12 degrees inside there, 12 degrees. Then the angle 56 degrees is over here between this tangent and this chord is 56 degrees. All right? What do they want us to do? Now, sometimes it is good to sort of recognize some of what you have already. Like, for example, you can see that this is a cyclic quadrilateral right here. That is cyclic. So the opposite angles are supplementary. What again? This is an isosceles triangle right here. Because it's a sector triangle. What are some other things? Mute the mic, please. Mute the mic. This is a tangent and a radius. So this angle is 90 degrees. Mute your mic, Maura. Mute your mic.
stay with us.
All right. Also over here, you have radius and tangent. That is 90 degrees as well. So since you know, for example, right here is 48. You know the rest of this make 90. That's going to be 42. All right. So you know that already. And if all of this is 42, look at it. And this is 12, means that right here, so it's 30. So you start to identify some things already. I don't even know what they're going to ask you yet. All right. Another thing, this is the angle between this chord and this tangent. It is 56. It means that the chord subtends 56 at the circumference up here. Let me use a different color. It means that the chord subtends the same 56 up here. So this angle is equal to 56 as well. Because the angle between the tangent and the chord is 56. So the chord subtends the same 56 at the circumference. So this angle is 56, yes? Huh? Where? Here, so? This is 30. And this is going to be 30 as well. All right? No, lie. 42. This is 42 and this is 42. Right here says 30. This is 42 and this is 42. We can answer the question. We cannot pray. Let us answer the question. Let us answer the questions. Because oftentimes they can't ask you everything. They won't ask you everything. This question says, find the value of angle KOL and give reason for each step in the answer. So they basically want us to find this angle right here at the center, right here. KOL. But there are multiple ways to do this question. You know? Not one way to do the question. Okay, look what I can do. I can do it. I can do this. I can say, okay, the angle between, look at this. I'm going to show you. I can say the angle between this chord. Remember, I know this angle that I want is subtended by this chord. If I follow the process that I told you earlier, they ask me for this angle. This angle, if I come back along it and come back along it, it is subtended by this chord. What is this chord doing? It is making an angle of 48 degrees with this tangent. What is the same chord doing? It's making an angle of the same 48 up here at the circumference. Is ready. So this chord is also subtending this angle at the circumference up here. So this angle must be 48 as well. That's at the circumference. But the same chord is subtending this angle at the center. Angle at the center is twice angle at circumference. And so the angle at the center here is 2 times 48 degrees. That's one way to do it. Another way to do it is to say, okay, this is a radius and this is a tangent. Right? So the whole of this angle is 90 degrees. So it means that right inside here so is 42. 42. Right? Because you subtract 90 minus 48 is 42. So it means that because that's an isosceles triangle, means that this angle is also 42. And then total angle in the triangle is 180. So this angle inside here becomes 180 minus the 42 and the 42, which is 84. So it equals the same 96. So sometimes it's a matter of which approach you use. Sometimes we don't even know which approach is the easier approach to use. You get me? Sometimes we don't even know which approach is the easier approach to use. There's a rule that says as well that the angle between a tangent and a chord is half the angle subtended at the center by the chord. So this angle becomes 2 times the 48 degrees. There's that rule, but it is not used so often. But that rule exists. But I'm going to use it now. Angle between a tangent and a chord is half the angle subtended by the chord at the center. Why? Because remember, the same chord will be subtended the same 48 at the circumference. So the same chord will subtend now twice as much at the center. So the angle at the center right here because it's subtended by this chord, and the chord is making an angle at 48, then the angle at the center is 2 times 48 degrees. Angle between a tangent and a chord is half the angle subtended by the chord at the center. So the angle at the center is twice this one out here as well, for the same center rule. So I'm going to use that. All right, so I'm going to say that the angle KOL becomes 2 times 48 degrees, which is the same 96. That's a quick way to do it. What's the reason? Angle between tangent and chord is half the angle subtended by the chord at the center. So you see, this rule is like you combine the tangent and chord rule and the center rule. Because the angle subtended by the chord at the circumference is equal to the angle between the tangent and the chord. Let's look at it again. Right? This chord, because it's making an angle of 48 degrees with the tangent here, the chord is going to subtend the same 48 degrees at the circumference up here. So this angle up here so is 48. But then the same chord will subtend twice as much at the center. Because the angle at the center is twice the angle of the circumference when they are subtended by the same chord. So this angle becomes 2 times the 48 degrees that is here, which is the same angle that is here. So that will combine the rules, basically. All right, so that angle at the center there is 96. All right. Online, everybody good with that?
Yes, sir.
Online, good?
Yes,
Yes,
sir.
sir.
All right.
Yes,
So this
sir.
angle inside there is 96. I like to populate the diagram. As you find them, you put them on the diagram. All right. It's good practice. So this is 96. Why the pen giving me that? Let me see if I'm using the right pen. Yes. 96 degrees right here. All right. So I found that one. I'll give the reason. Now, what I find them doing in CSET these days. So you see, they give you just one question, they'll ask you for the reason. Then they give you all these angles down here, no, but they don't ask you for any reason. They just wanted to calculate them. So that's what I find they're doing recently. They might ask you 1 or 2 with reasons, and then they ask you just to calculate others. And you don't have to actually write out the reason. We're going to indicate the reason still. So this angle now wants angle LMN. Let's look at the diagram. Which angle is that? LMN. Let's look at the diagram. Angle LMN. Let's look at it. Angle LMN. That's this. L to M to N. So they want all of this angle now. That's pretty easy. If I look at it, we're going to get that angle. So I want that angle over here, right? This angle. Let me zoom it up. Now remember that because the angle between this tangent, this chord, sorry, and this tangent is 48, then this chord subtends the same 48 up here. So this angle is 48. So this piece of the angle is 48 degrees. I'm going to break it down into 2 parts. So this angle right here is 48 degrees. And then now, this piece over here, let me use a different color for that part. This piece over here is subtended by this chord. See? If you come back along the angle to find the chord, it is subtended by this chord, this angle up here. And that chord is making an angle of 58 degrees with the tangent out here. So it means that this same angle is inside here. Because the angle between a tangent and a chord is equal to the angle subtended by the chord. And so this angle here is also 56 degrees. And so the angle that I want, so I'm going to now mark in blue, is the sum of those two. Those two. Sum of those two. Now there's another way we could find it, you know. There's another way we could find it. This blue angle that we want is one of the angles in this cyclic quadrilateral. See there? This cyclic quadrilateral. It is opposite to the one over here in the cyclic quadrilateral. All of that. So see these two angles, they add up to 180 degrees because they are opposite angles in the cyclic quadrilateral. These two angles that are marked in blue. They add up to 180 degrees. These two, they add up to 180 degrees. I want to find this one. So the question is, what is this one in here equal to? That one in here, this one inside here, is 180 minus these two, you know. Because what? Total angle on this straight line is 180 through this point. This piece is 48 and this piece is 56. So the remaining piece in between here must be 180 degrees minus the 56 and the 48. And then if these two must add up to 180, then this angle has to be these two, which is what we're getting here as well. 56 plus 48. That's another way to do it. But I think I'm going to go with this method, that I broke up the angle into two parts, and I'm going to add it up as 48 and 56. So let's write it down here. So this angle that I want, I'm going to put it as equal to 48 degrees, part of it, and 56. What is add up to? 104, right? 104 is correct?
Yes, sir.
104, good. All right, which angle do I want next? KLO. Let's look at it. KLO. Where is that? KLO. KLO. That's easy. That's this angle. That's one of the angles in this triangle, which is isosceles. And if you already know that in this isosceles triangle now, this angle is 96, then these two angles are gonna be equal. Another way to do it is to say, okay, since we want this angle, it is equal to this one. And the angle here is 90 because it is the angle between this radius and this tangent. So this angle here is 42 degrees. So this also must be 42 degrees because of the isosceles triangle. But I think most persons would maybe just use the fact that this is an isosceles triangle. You want to find this one. You know this one up here. These two angles equal. And so this one that you want will be 180 degrees minus the 96. And then because these two equal, you're going to divide that by 2. Right? So then it work out to what? 40 what? 42? 42 degrees, same here. 42 degrees. So I might give them this calculation. Let's copy this down. All right, so use an isosceles triangle there for that one. All right, 42. Let's put it on the diagram and leave it there, right? So that is 42. Let's take this off. Put in the 42. So I'm going to put this as 42 degrees. I'm going to put this as 42. Well, if this is 42, then right here says 30. Because the whole thing is 42 and this is 12. So right here has to be 30 degrees right here. That has to be 30. So you can mark that on the diagram. All right. Mark that on the diagram. All right. Let's continue. Next angle I want is angle MLK. Angle MLK. Where is that? Angle MLK. MLK. That is this angle over here. But that one kind of easy now, because what we can do, let me take off this blue line. What we can do now is focus on this triangle. And in that red triangle, you know these two angles. You know this angle is 30, and you know this angle is 48. The question is asking us for this angle over here in blue, MLK. So it's 180 minus the sum of those two. So this angle becomes 180 degrees minus the 48 and the 30. So you're subtracting 78 in that red triangle. What that work out to? 102? 102 degrees. So I'm going to show this one down here. All right, so we're going to put that down here for this one. Paste it. 102. And the last question now is asking us for angle KNM. KNM. Let's look at it. Which angle that is? Angle KNM. Let's take these off. So angle KNM now is, see there, K to N to M. So it's basically asking us for this angle. Now this one kind of easy, because if we complete this cyclic quadrilateral, this blue angle that we just found here is supplementary with this one over here that we want now. These two angles add up to 180. You get me? So it means then that this angle in here is 180 degrees minus this 102, which is the same 78 degrees. But let me show you another way you could get this angle up here. Show you another cute way to get it. Watch this now. So it's 78 degrees, right? Show you another way that I just saw. Watch this now. Watch this, watch this, watch this, watch this. Watch this other way. Let me take these off. All right. So let's say we're trying to find this angle up here. I'm going to come back and find the chord that is subtending this angle. So I come back to the circle to here. Then I come back on the other side of the angle to here. So the chord that is subtending that angle, let me put a different color, is this purple chord. This purple chord is subtending that angle. This purple chord is subtending that angle. And I can say to myself, okay, what else is that chord doing? Don't forget 78 as the answer now. Don't forget. What else is that chord doing? That chord is making this angle with the tangent out here, so. See there now? What is that angle? That angle is 48 plus 30, 78. So the chord is going to subtend the same 78 degrees over here. Because the angle between a tangent and a chord is equal to the angle subtended by that chord at the circumference. That's another way you could have gotten the 78 degrees. What about that? So we use a cyclic quadrilateral or we use a tangent and chord rule. And sometimes that's how you know the answer correct. You can get it two different ways. So it is 78 degrees. So we can use the method of adding the 48 degrees and the 30 degrees to get the 78 degrees. Or we did the 180 degrees minus the 102 in the cyclic quadrilateral to get the same 78 degrees. And that is it. All right. I think that finishes that question. Very good. Online okay?
Yes, sir.
All right. Let's do another one. Let's do 2023. So that's the 2024. Let's do 2023, which is a June last year. Let's do that one. June 2023. All right, let's do that one. Remember, we're gonna do another marathon next. Well, we're doing a marathon tomorrow. Right? Doing a marathon tomorrow. Which topic we say we're doing tomorrow? 4 o'clock. So vectors and what?
Matrices.
Matrices. Vectors and matrices tomorrow. Okay. So the matrices we're doing tomorrow is not the, with the transformation. We said vectors and transformation, not matrices. Okay. So it's vectors and transformation.
No, sir, all theory.
Huh? No, man.
theorem,
I listed out what we're doing already. I don't think I said matrices. What are the matrices next week? I want to focus on the transformation, not the matrices. Let me just check.
Sir, can you explain everything like when you're doing the class?
But I'm doing what?
I think sir would have sent it in the group.
I sent it in the group. Yeah, let me just check the group. Somebody asked a question about explain everything. I can't teach everything from scratch, but I'll just kind of do a little brief of the main points as I did today. All right, I'll do a little brief before we start doing the questions of the main things to look out for. We're doing the transformation. The transformation is a lot of stuff, but I tried still to do the main things. Let me
Okay,
see. Hold on a second. Let me just see what I said I was gonna do. I said I was gonna do. All right. So tomorrow we're doing vectors and transformation. Tomorrow we're doing vectors and transformation, and some of the transformation will be the matrices type. I don't know. We'll do the matrices next week. The matrices next week. All right. That's what I'm gonna do with May 2013. Right? May 2013. Where is it? Where is it? May 2013. (2023), not 2013. 2023. All right, this is it. 2023. Here you go. There's a nice looking one, similar to the one that we just did. All right, let's go. This question said, let me see if it's similar. So they said, calculate given reasons angle R, right? And then this one as well, or they want reason for all of them. All right, they want reasons for all of them. 1, 2, 3. Just 3 angles I want in this one. All right, let's go. This question says, L, M, N, and R are points on the circumference of a circle. Center of a circle right here is O. PQ is a tangent right here. And then they give us this angle 48 degrees. That's the angle between this chord and the tangent is 48 degrees. All right, so you have tangent and chord rule, remember. The angle RON is 156. This is the angle at the center. Remember, angle at center is twice the angle at circumference. So automatically you know that this angle up here is half of this one, because they are both subtended by this chord. Or you can say they are both subtended by this arc. This arc is subtending 156 at the center, so it subtends half the amount at the circumference. You see that already. So sometimes you just identify some things right away. And we can look and see right here, and between this tangent and this chord is 48 degrees. Stop talking, please. It means that the chord is going to subtend the same 48 degrees at the circumference up here. So it means that the angle across here is the same 48 as out here. Tangent and chord rule. All right. So we're seeing some of that. What about this angle here, the A? I would say that the A is one of the angles in this cyclic quadrilateral. It is across from this one, these two. Must add up to 180 degrees, those two. Across from each other in the cyclic quadrilateral. Another thing, we can identify, just identify a couple things before we start. Angle between this tangent is a red. Let me use a red. Angle between this tangent and this chord is this angle E right here. It means that the chord is going to subtend the same angle E at the circumference. So it simply means that this R angle right here is equal to the angle out here. All right. So those are some of the things that I've identified already. But let's answer the questions in the sequence that they gave us. First answer must calculate, given reasons, show our working angle R. And angle R is this angle right here. So let's look at the chain of thought. Let's say you look at it and you don't know. Look at how you process to find this angle R. Let's look at it. What I said you do, since you want to find this angle, go back along the sides forming the angle until you reach the circumference of a circle. So you can see what is subtending the angle. So I come back along the sides, forming the angle, the lines forming the angle, and I realize that it is this chord that is subtending that angle. See here, I'm going to draw the chord. When I get a chord, I'm going to draw a chord. If it's an arc, if this chord wasn't there, then I would have said it is this arc. But since this chord is there, I'm going to then focus on the chord. What else is that chord doing? What is glaring that the chord is doing, this chord? That chord is subtending this angle at the center, 156. And you know that the angle at the center is twice the angle at the circumference. The one at the center is the big one. So it means that this angle up here is half of the 156. Because the one at the center is bigger than the one at the circumference by 2 times. So it means that R is equal to half of 156. That is how you can process it. So you can write it here. The angle R is equal to half of 156 degrees. Half of 156 is how much? 78. What is half of 156? 78? Huh? 78 degrees. What's the reason? Because the angle at the center is twice the angle at the circumference. And this angle is at the circumference. And the one at the center is 156. Or if you like, you can say the angle at the circumference is half the one at the center. But I normally prefer to write the rule the same way every time. So I'm going to write it like this. Angle at center is twice angle at circumference. That's the reason. I don't need to write anything more than that. They give it a marks if you write that. And I'm going to put it on the diagram. I'm going to put it on the diagram now. So this angle up here is 78 degrees right here. 78 degrees is this angle. Next angle I want is angle E. Easy. Angle E, Again, if you want to process it and use a process, I know it's equal to this already, you know. But let's say you don't know, you want to process it. You look and say, okay, what is angle E? Angle E is the angle between this tangent and this chord. And you know that there's a tangent and chord rule. You have to know that the rule exists. This is the angle that you want. What is the chord doing? The chord is subtending this 78 at the circumference. And the rule says the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in alternate segment. So it means that this angle is also 78 degrees. So E is 78 degrees. Simple as that. Tangent and chord rule. So we're just going to write it. This angle E is equal to 78 degrees. Reason, because angle between a tangent and a chord equals the angle subtended by the chord. This is just like an abbreviated way of writing the rule, but if you write that, they give it a marks. Angle between tangent and a chord is equal to the angle subtended by the chord, equals. So that angle out there is 78, right? So this angle out here is 78, so I'm going to write it. This angle out here is 78 degrees as well. 78 degrees is this angle. Next angle I want is angle A. Angle A. Let's look at it. Angle A is this angle right here. All right. So if I come back and I find the chord that is subtending the angle there, or the chord that is subtending this angle A is this one. I might say, okay, what is this chord doing? It's not doing anything material. Yes, it is. It is subtending an angle on the other segment over here. Look, over here, it is subtending another angle over here. Down here, so. So I have a cyclic quadrilateral. So the angle A is an angle in that cyclic quadrilateral. Let's take out this now. So it means that this angle that I want, the A, and this angle over here, they are supplementary. So if I can find this angle inside here, then I subtract it from 180 to get this one over here. But basically, we could maybe see that this angle over here is going to be the sum of these two, this and this. It's going to be the sum of those two. Press the wrong thing while I go in. Right? It's going to be the sum of those two. But if you like, you could proceed to find the angle inside here. So first, let's do it in red. The angle inside here is going to be 180 minus these two, because of the total angle on a straight line is 180 across here. So in between here is 180 minus the 78 and the 48. So it's 180 degrees minus the 78 and the 48. And then the angle A that you want up here is now 180 minus all of that. So it's going to end up being the same 78 plus the 48. If you look at this and say this angle then is 180 degrees minus all of this. 180 minus the 78 and the 48. Then the 180 minus the 180 gone. And a minus means it's a plus. So it simply works back out to 78 degrees plus 48 degrees. That is what it is. 78 plus 48. What's that work out to?
126.
One much?
26.
126 degrees. That is it. So we cycle quadrilateral rule. Find this one here first, and then use the cycle quadrilateral to get it. All right, I'm going to stop it there. That will be the answer for this part down here. So. And you could say that you use a cycle quadrilateral. So let's write it. Let's write. We're going to say it is equal to, it becomes the 78 plus the 48, just the same. So this angle becomes equal to 78 plus the 48 degrees, which is the 126. And it's because the opposite. And when you're doing the cycle quadrilateral rule, you have to write the word opposite. Plenty people have the habit of just saying angles in a cycle quadrilateral. Wrong, that's wrong. You have to say opposite angles in a cycle quadrilateral. Opposite. You have to use the word opposite. Opposite angles is a symbol for angles in a cyclic, you can say cyclic quad. You know this means quadrilateral. They are supplementary. Supplementary. Supplementary means that they add to 180 degrees. That's what we used for that one. I think this one finished. All right. I want to do a two tangents rule one. I want to do one that has two tangents in it. There's one on 2015, January 2015. Let's go for that one. January 2015. Let's go for that one. January 2015. January 2015, right here. All right, I think this one has two tangents on it. All right. January 2015. Where are you? Where are you? There you go. Two tangents from a single external point. Let's go. This question says, diagram below not drawn to scale shows a circle center O. HJ and HG are tangent to the circle, where the angle inside here is 48 degrees. Question says, calculate given reasons for each step in the answer, the measure of angle OJH. OJH. O to J to H. That's this angle right here. That has to be 90. Because the angle between a radius and a tangent. Tangent and radius rule. Easy. Angle between a tangent and a radius is 90 degrees, the point of tangency. So this angle equals 90 degrees. What's the reason? Because angle between a tangent and a radius is 90 degrees. Done. Angle between tangent and radius is 90 degrees. Done. So that angle is 90 degrees. Next one. JOG. Right here. JOG is this angle. I say the two tangents, you have to know that the two tangents together with the two radii is a cyclic quadrilateral. Why? Because this angle over here is 90 and this angle over here is also 90. So these two must add up to 180 degrees. And so the angle that they want inside here is 180 minus this one. 180 degrees minus the 48 degrees. How much is that? 132. That's correct. 132. Because these two angles are supplementary. What is the reason? Because the two tangents and the two radii is a cyclic quadrilateral. The opposite angles are supplementary. That's the reason I'm going to tell them. All right? So let's go. I'm going to say it to the examiner. That's not the only way, but it's a good enough way. This angle becomes 180 degrees minus a 48 degrees on my diagram, which works out to be 132 degrees. What's the reason? The reason is that this thing is a cyclic quadrilateral. Let's name it. JOGH. JOGH is a cyclic quadrilateral. JOGH is a cyclic quadrilateral. The opposite angles are supplementary. Or you can say they add to 180 degrees. That's how we subtract from 180. You're telling them that that shape is a cyclic quadrilateral. And because it is a cyclic quadrilateral, the opposite angles add up to 180 degrees. That's it. Next question. J, yes?
Did you say 2 radius?
2 radii. The 2 tangents and the 2 radii together makes up a cyclic quadrilateral. Yes?
Where's the other radius?
So one here so and so one here so. See it? 2 tangents. 2 tangents. Let's look at it. Let's look at it. The 2 tangents. Look. Tangent. Tangent. Radius. See that one? That's one. See the other one here? Radius. So these 2 tangents together with these 2 radii is a cyclic quadrilateral. Why is it cyclic? Because the angle between this tangent and this radius is 90 right here. Angle between this tangent and this radius is also 90 right here. This red thing is a quadrilateral. These 2 angles, they are each 90. They already add up to 180 degrees. Total angle in a quadrilateral is 360. If these 2 add up to 180, then the other 2, which are across from each other here, must also add up to 180, such that the total in there is 360. And then because we have a quadrilateral here, where the opposite angles are supplementary, it means that it is cyclic. And that will always happen. It will always happen when you have the 2 tangents combined with the 2 radii in the circle there. You good now?
Yes, sir. Thank you.
Beautiful. All right. So it says 132 inside there, right? 132. All right. 132. So this angle is 132 degrees. All right. Let's go. What next? Next angle I want is JKG. 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 Let's see where that angle is. JKG. They're talking about this angle right here that we want next. Easy. Let's look at it again. The thought, the chain, the thought process. I see what it is already now, but let's say you don't see what it is. How do you work it out? So you want to find this angle up here. What you do? Go back along the sides, forming the angle until you reach a circumference. So you go back to here. Go back along the other side until you reach a circumference. Go back to here. You look and see if there's a chord subtending the angle, which they didn't show you any. They don't show you a chord. They're looking at the arc that is subtending the angle. So an angle can be subtended by a chord or it can be subtended by an arc. In this example, because they did not show us a chord, then we're going to be working with this arc. So this red arc is going to be subtending this angle up here. What other angle is this arc subtending? Or you know what angle it's subtending? The lines that come from this point here. These are lines come from this point that is now subtending this angle at the center. So the arc is also subtending this angle at the center. And so we'll go for the center rule. Because the angle at the center is twice the angle of circumference when they are subtended by the same arc or subtended by the same chord. This time, those two angles, this one and this one, are subtended by this arc. This one is at the center, this one is at the circumference. The one at the center is twice, so the one at the circumference is half. So this angle out here that we want, this angle out here that we want, becomes half of the 132, which is what? That looks like 66 degrees. Agreed? So it's 66 degrees. The reason?
Yes, sir.
Because the center rule. Angle at center is twice the angle at circumference. So one at the circumference is half the one at the center. So we're going to write that. That angle that we want is half. This angle here becomes half of the 132 degrees, which works out to be 66 degrees. Why? Because angle at center, so all we need to write is twice the angle at the circumference. That's the reason. The reason is more expansive than this, but if you give them that, they give it the marks. Believe me. Angle at center is twice angle at circumference. If you want to write out the whole thing and you know it, no problem. I'm telling you the minimum that you must write to get your marks. Next thing they want, angle JLG. Let's go up here now. Angle JLG. So I'm going to take these off the diagram now. I'm only leaving the angles that were found. So the angle they're asking us for now, let's put this, yes?
Can you do one more after this?
Yes, man, no problem. More mass equals better mass. You mean what another parallel, what another two tangents rule one?
Yes, sir.
All right. Yeah, there's one on 2018 as well. All right. So the next question is asking us for angle JLG, which is this angle in here. And this is where a lot of people make a mistake. Right here. A lot of people run and say that this angle is 180 minus 132, which is wrong. Because they are seeing this as a cyclic quadrilateral, which it is not. It is not a cyclic quadrilateral because this center is not on the circumference. For it to be a cyclic quadrilateral, the four vertices must be on the circumference. So that purple one is not a cyclic quadrilateral. So this calculation will be wrong. I'm telling you, a lot of people make this mistake. All right, so make sure you don't make it. The cyclic quadrilateral here is actually now this one. This is a cyclic quadrilateral. I'm going to mark it out for you now. I have to come back up here to the circumference. This now is cyclic. The four vertices are on the circumference. So that one is cyclic. And so that angle that we want over here is supplementary with this one across from it. These two angles, let me take out this 132 all the way. These two angles now are opposite each other in the cyclic quadrilateral. They are supplementary. I will know that this one is 62. So it means that the one down here that we want is now actually 180 degrees minus, not 62, 66 degrees. which becomes 114 degrees. That is it. Cyclic quadrilateral rule. You have to pick the right cyclic quadrilateral. But go to that. But understand that?
Yes,
But
sir.
good.
Yep.
All
Yes,
right.
sir.
So it becomes equal to 180 degrees minus the 66 across from it. And the other circumference, 114 degrees. Reason? Because opposite. Remember, you have to put the word opposite. When you are stating the cyclic quadrilateral rule, you cannot just say angles in a cyclic quadrilateral. You have to say the opposite angles in a cyclic quadrilateral. If you don't put the word opposite, you might lose a mark. So you have to say opposite. It is the opposite angles that are supplementary. Opposite angles in the cyclic quad. You can just write quad for quadrilateral. Are supplementary. Supplementary simply means that they add to 180 degrees. Now, for this question, I remember CXC set a question like this some time ago, and there was a last part of the question. I don't remember which year it was. Let me take these off. And the last part of the question said, explain why this is a cyclic quadrilateral. Question was to explain why this is a cyclic quadrilateral. Now remember, these vertices are not on any circle. So you cannot say that it is because the vertices are on the circumference of a circle, because those two that have circled, they are not on any circle. It is cyclic because it is possible to fit a circle that passes through the four vertices. Yes, it is. So maybe a circle would maybe go like this and pass through the four vertices like that. But in this case, the reason why it is cyclic is because the opposite angles are supplementary. Remember, this was 132 we worked out. This is 90 up here, and this is 90. These two add up to 180, and these two add up to 180. And so the reason why this is cyclic is because the opposite angles are supplementary. So if you were to write that in an exam, if they ask you that, why that thing cyclic, you'd have to say something like this. JOGH is cyclic because JOGH, stop talking, man. Just a talk. JOGH is cyclic because the opposite angles are supplementary. That is why this one is cyclic. Add to 180 degrees. So after that, that's the way you have to say. If you get back one like this. All right, so somebody is asking for another two tangents rule question. So there's one on 2018. So let me go on for that one. There's one on January 2018. Let me find it. January 2018 has one on there. See it here? January 2018. What time is it now? All right, we have another hour now. No, I'll leave before the hour. I'm good to go because I'm going to know everything, you know. Until I'm going to the mock exam for though. So now I'm going to know bossy. I can know everything. Go on, man. All right, so one here. Two tangents. See, two tangents. Let's look at this one. More maths equals better maths. Let's go. This question says, the diagram below not drawn to scale shows a circle center O. It says the points A, B, C, and D are on the circumference of a circle. EAF and EDG are tangents to the circle at A and D respectively. And the angle at O right here is 114 degrees. And the angle CDG out here is 18 degrees. All right? And I want us to calculate, given reasons for each support in our answer, these angles: ACD, AED, OAC, ABC, a lot of parts. All right? All right, let's go. I like these questions, a lot of parts. All right. So what are some of the things we can recognize before we even start? What are some of the things? Let's look. This triangle is isosceles. Let me zoom it up some more. This triangle inside here is isosceles because this is a radius and this is a radius. That's an isosceles triangle. And so it is easy to find these two angles because you know the one here is 114. So it's easy to find those two angles. Watch this again. This angle at the center, to come back, is subtended by this chord. The same chord is subtending now this angle over here at the circumference. Same chord, you know, that same blue chord is subtending this angle at the circumference up here. This angle. Both of them subtended by this chord. The one at the center is twice. So it means that this angle is half of the 114 degrees. That's something that I've recognized. Half of the 114. All right? I'm not answering the questions yet, you know. Watch this now. I'm just showing you some things that I picked out. Remember now, these two tangents together with these two radii is cyclic. So since this angle is 114, then this angle across summit here is 180 minus the 114. Good? 180 minus the 114. All right. What again do I recognize? Let's look again. This is a tangent. This is a chord. The angle between them is 18 degrees. What does that mean? It means that the chord is going to go and subtend the same 18 degrees at the circumference over here. So this angle is also 18 degrees. This angle is also 18 degrees. Tangent and chord rule. Tangent and chord rule. All right? Remember also that this is going to be an isosceles triangle. This. Why is it isosceles? Because this radius and that tangent, sorry, and this tangent, they are equal in length. So that is isosceles. So if you find this angle from this cyclic quadrilateral, then we can also go on and find these two angles. All right? I'm just identifying some stuff before we start. What else? What else? That's a cyclic quadrilateral here. The opposite angles in that are supplementary in that cyclic quadrilateral. All right. All right. Let us answer the questions. Let us answer the questions. All right. Yeah. Is this tangent? Up here, up here? Huh? OB? O what? OD? Oh, this is that radius. That's a tangent, so this is 90. So therefore you can find this angle right here. This angle right here is going to be 90 minus the 18. I can answer the questions. Then. I can answer the question. A lot of things, they can't ask you everything, right? It is impossible. They can't ask you everything. All right, let us answer the questions. First part wants us to find angle ACD. Where is that? Angle ACD, right here. Angle ACD. That's this angle. What did I say you do? You find the chord and look what else the chord is doing. But come back along the side to here and come back along the side to here. Then this is a chord that is subtending this angle up here right now. What else is the chord glaringly doing? What else is that chord glaringly doing? It is subtending this angle at the center, sorry. 114. The same chord will subtend half as much at the circumference because the one at the center is twice. All right, so this angle out here that I want is half of the 114. I said it before. All right, because the angle at the center is twice. So let's work it out down here. This angle becomes half of the 114 degrees, which becomes 107, 57 degrees. Agreed? That's 57 degrees.
Yes, sir.
What's the reason? The reason is that angle at the center is twice angle at circumference. So they don't need to give a lot of space, but I wanted to give a reason though. I'm going to write it right here. Angle at center is twice angle at circumference. Angle at center is twice angle at circumference. Angle at center is twice angle at circumference. Next angle, let's put on the angles. As soon as you find it, put on the diagram because it will help you find something else. So this angle up here is 57 degrees. Let's put it in there. 57 degrees right here. Make the pen look smaller and write it. Just bear with me, guys. 57 degrees. 57 degrees. This angle in here. All right. What else I want? Let's continue. Next angle I want is angle AED. Let's see where that is on the diagram. Angle AED. Angle AED. That's this one, you know. That's this one I want right here. This one easy. Remember the two tangents and the two radii together forms a cyclic quadrilateral. So this angle, these two angles up to 180. And so the one that you want down here is 180 minus the one at the center there, 114. All right, what I work out to? 180 minus 114. How much is that? How much is that?
66.
How much?
66.
66 degrees. Thanks. All right, let's put it on 66 degrees. So this angle here now is 66 degrees. 66 degrees. All right, let's go and write it. So this angle becomes 180 degrees minus the 114 degrees, which is 66 degrees. I'm going to tell him the reason is that this thing is cyclic and the opposite angles are supplementary. So I'm going to say OAED is cyclic. OAED is cyclic. Let's tell him. Reason. OAED is a cyclic quadrilateral. The opposite angles are supplementary. Or they add to 180 degrees. Opposite angles add to 180 degrees. That's why that angle is 66. Next angle I want is what? Angle OAC. Let's see where that is. OAC. OAC. All right. So the angle that I want right now, let's zoom up on it. They're asking us for angle OAC. That's this like a small angle right here. That's what they want. So to find that angle, what we're gonna do, we're gonna use the information that we have. Because we know this isosceles triangle, we can know all of this angle, which I'm gonna put in blue. We can know all of this angle in this isosceles triangle, right? But then we also know that this angle here is 18. So you have to be thinking, this angle here is 80. Why is it 18? Because this angle here in purple, if I come back, is subtended by this chord. It's subtending this angle in purple. And that chord is making an angle of 18 degrees with this tangent out here. So it means that the chord subtends the same 18 degrees inside here. So that purple angle inside here is 18 degrees. Right? So this purple angle right here is 18 degrees. And then what is the blue angle now? This blue angle and this angle over here, they're equal because they are angles in this isosceles triangle. Remember, if you know one angle in an isosceles triangle, you are blessed because you can find the other two easily. Any one angle you know in an isosceles triangle, you're blessed because you can find the other two. So this angle out here, this blue angle out here now, in the isosceles triangle is 180 degrees minus the 114 degrees, but then we have to divide it by 2. Why? Because it is these two add together for the 118, 180 minus the 114. All right, so that's actually 33 degrees each. That's 33 degrees. So this becomes 33 degrees. But can I agree with that?
Yes, sir.
33 degrees. Yes. And so that red angle that we want, that little red angle right there, becomes 33 minus 18. Because the total angle is 33. This part of it is 18 right here. So the red angle that the question is asking us for up here
Degrees.
is 33 degrees minus 18 degrees. How much is that?
15.
15?
Yes, sir.
15 degrees. And I'm leaving these calculations on my page, on my diagram, to help explain my reason. All right? But I think I have to tell them about at least this one. All right? So I'm going to say it is 33 minus 18. So I believe just the 18 here I didn't explain. I think this calculation shows the thing there. We can maybe put isosceles triangle here to show the reason for this one. So I can maybe say for this one, total angle in the isosceles triangle is 180 degrees. Total angle in the isosceles triangle is 180 degrees. That's the premise on which we calculated that 30. And then for the 18 degrees here, can we put over here and tell them that this angle, which is now angle CAD, can say angle CAD is equal to the 18 degrees out here. Why? Because angle between tangent and chord equals angle subtended by the chord. So sometimes you have to do these things. Put some of the explanation on the diagram there, because you don't have enough space to put it down there. And then we're just going to write the answer now. The 33 minus 18 is 15. So we show them how we get the 18, put the reason for the 33, and they just put the answer at the bottom. All right. So we're going to come down here now and put the 33 minus 18 here. So this angle becomes 33 degrees minus 18 degrees equals 15 degrees. And for the reason, I'm going to say C diagram. See the diagram for the reason. The reason is on the diagram. All right. Anything else? Yes, another one. Angle ABC. Angle ABC. Angle ABC. That's this one up here. A to B to C. So the angle I want now is this one up here. This one. Angle ABC. All right. Look, we're going to get that one now. All right. All right. So firstly, this angle up here in this cyclic quadrilateral is opposite to this one. So that, and we can find this one because in this triangle, we know two of the angles. In this triangle, we know two of the angles. We know the 57 and the 18. And so we're able to find this one in here. And once we find this one, is 180 minus this one gives us that one up there because they are supplementary. All right. But is there another way to do it? Everybody see that method that can be used? You can find this one first using that triangle and then the 180 minus that to get this one. But let's see if we can look at another way. Let's work out and see what we would get and then we'll test it another way. So firstly, this angle inside here would be 180 minus the 18 and the 57. This one in here will be 180 degrees minus the sum of the 18 and the 57. Somebody work this out for me, please. Then what they get? 105. This works out to be 105 degrees. And so this angle up here now is going to become 180 degrees minus the 105. Cyclic quadrilateral rule. 180 degrees minus the 105, which is giving us 75 degrees. All right. But let's look at another way to get it now. More maths equals better maths. Let's look at another way. Watch this now. Let's look at another method. All right. Let's use a different color to show it. Let's use the green. All right. Watch this now. Let's say using the approach that I told you, where you find the chord and look what the chord is doing, right? So if I were to come back along the sides, making this angle, come back till I reach the circumference, come back until I reach the circumference, then the chord joining those 2 points on the circumference will be this chord, this green chord. So it is this green chord that is subtending that angle. We know so the chord making a cyclic quadrilateral over here, in the opposite side, in the next segment, you know. But look what this now. Remember that this is a tangent over here now. That's a tangent. So if we can actually find this angle between the tangent and the chord, then it will be equal to the angle subtended by the chord up there. So the question is, what is this angle right here? How can I find that angle? Hey, what man?
Right.
We can find this angle here now because this piece is 18. So what we would basically need? What we basically need for that green angle is this other piece, which we can find that other piece because remember that this is an isosceles triangle. That's an isosceles triangle, you know. Why is it isosceles again? Because this tangent and this tangent, they're the same length. So this angle over here, these two angles are equal. So if we find this angle and add it to the 18, that's going to be this green angle between here. which then this angle up here will be equal to that. So let's do it that other way. So my aim now is to find this angle right here, just to do it another way. More maths equals better maths. So this angle here now, using this isosceles triangle as the basis for finding this angle, is going to be 180 degrees minus this 66 right here, divided by 2. That's 57. In fact, this angle is 57 for another reason, you know. Don't waste time, man. This angle right here is 57. This angle right here is the angle between this tangent and this chord. And this chord is obtaining 56 up here. So this angle right here is actually 57 degrees. Because it's the angle between the tangent and the chord is 57. And this chord is obtaining 57 at the circumference. So it means then that this angle is 57 as well. And so the sum of the 18 and the 57 is the angle between this green chord and this tangent out here for now. This green angle. The 18 plus the 57. And so this angle up here is going to be the same 18 plus 57. So that's another way to get this angle here. 18 degrees plus the 57 degrees. That also is 75 degrees. That's another way it could have been done. All right, tangent and chord rule. What about that?
Yes, sir.
Yep.
When you just say yes because you don't want to leave, you know. You can go on. Who want to leave? Leave. I'm going to stay online with the people until 9 o'clock. If you don't want to leave, you can go on for 2. If you don't go, you can go on for 2. I'm serious. Well, you need to stop your noise then. All right, let's continue. What time is it now? All right, we have half an hour left. Give me a good half an hour now. Give me a quiet half an hour. Nobody foolishness. I tell them that you father. I tell them. All right, let's go. One more question. Let's do another one. Online, you want another one?
Yeah.
Want another one? Somebody online said no. Huh? Shh, quiet now. Let me hear the people then. Huh?
Sir,
Yes?
is it done?
If it done? No, I'm prepared to go until 9 o'clock for another half an hour.
Okay.
So I'm prepared to do another one. Let's do 2019. I think 2019 was a kind of nice show. Relax. 2019, January 2019. I think we can finish with that one. January 2019. All right, see it here, January 2019. Let's look at January 2019. All right, people online. The people in the classroom been here since 9 a.m. this morning, you know, so them kind of restless. All right, kind of restless now. But you have to know more maths equals better maths. You have to study hard in order to pass easily. That's how it is. Let's do this one, and I'll call it a night. Khalid, stop the talking now. Let's go. This question says, diagram below not drawn to scale shows a circle. The points P, Q, R, you know, I realize when I don't know question, we don't diameter yet, you know, but it's all right.
P is 75. Oh, sorry.
Yeah, man, that's all right. It says, boom, bang, boom, bang. All right, so this angle is 75 degrees. This angle right here is 75 degrees up here. And this angle out here is 60 degrees, right? So everything that they have said is on the diagram. Now look here. They did not show the center. So you cannot assume that this is a diameter. You can't assume by how the diagram looks. See these words in bold letters? Not drawn to scale. So you cannot go by how anything looks. Another thing is that this line is not a tangent. A lot of people did this question and they treated this as if it is a tangent. A tangent touches a circle at a single point only. So this is not a tangent. You cannot go using any tangent rule. With this line, it's not a tangent. All right. What do we have here? This is a cyclic quadrilateral for sure. This is a cyclic quadrilateral. And we have yet another one here, cyclic. This one is cyclic as well. All right. This angle up here is not subtended by any chord. They didn't show any chord. It is subtended by this arc up here. All right. The same arc that is subtending this angle up here. This is the arc, you know. You can put in a chord if you want. And you can see it. The same arc under here is subtending this angle up here. So this angle is also 75. Same segment rule. All right. There's another rule I can tell you about. That if you have a cyclic quadrilateral, and you extend this side, then this angle out here is an exterior angle of that cyclic quadrilateral. Exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So this angle over here is also 60. But you can take the steps to get it, because you could say that because this angle is 60 and that's a straight line, then this angle is 120. Because total angle on a straight line is 180. So if this is 60, then this is 120. And then you could say that these two angles opposite each other are supplementary. And so this angle over here would come back with the same 60 as out here. But you can know the rule that says the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. All right? The more things you know, the better. And you're not going to know everything, but the more things you know, the better. Because when you know a lot of stuff, you get to the answers easier sometimes. All right? But let's see what they want us to find. They want us to find first the angle PTR. Where is that? PTR. That's the angle up here. PTR. Let's do the chain of the process. Let's do the process to find that angle again, one more time. So the question is asking for this angle. And some people say, oh, sure, I can't see how to find the angle. I'm going to find the angle. Follow the process. Find the object that is subtending the angle. Look what else the object is doing. The object subtending an angle is either an arc or a chord. How you find it? Come back along the side or the sides forming the angle until you reach a circumference here. Come back along the other side until you reach the circumference. So you see, note I didn't stop here, so you know. I came all the way back to the circumference here. There's no chord shown there. You can add a chord to it if you want to know. I'll make it clear right now. But if they don't show a chord, then it is the arc under here that is subtending the angle. Let's look at it. This arc under here, this blue arc, is subtending that angle, that red angle up there that we're trying to find. What else is this arc subtending? That arc is also, if you draw lines from here and here now, up here, it is also subtending this angle up here, which is 75. The same blue arc is subtending that angle up there, 75. The same blue arc is subtending that angle up here, 75. As I said, if you want to make it clear for yourself, you could draw in the chord for yourself if you want and work with the chord instead. That blue chord is subtending those two angles. They are the same segment. They are equal. Same segment rule. All right? But they didn't put the chord for us. they put an arc, but it's still the same segment rule. So that means that this angle inside here is same 75 as that. 75 degrees. Same segment rule. Angles in the same segment, subtended by the same chord or subtended by the same arc, they are equal. So this angle is simply equal to 75 degrees because angles in the same segment are equal. If you want to add on to that and be more expansive and say when subtended by the same arc or when subtended by the same chord, that's fine. But I guarantee you, if you give them this, they give you your marks. All right? Some teachers might tell you to write out everything. So if you feel more comfortable writing out everything, that's fine. Write out everything. All right? Next part. The one angle TPQ. TPQ. Let's see where that is. All right, so I'm going to take all these markings except the 75 degrees. So angle TPQ now. TPQ. That's this angle we want now. We don't say that it is 60 degrees, you know. We'll do it again. That TPQ, you would maybe come back. Well, this is the arc that is subtending it, yes. There's no chord. But you must see that it is one of the angles in the cyclic quadrilateral. You must see that. And the cyclic quadrilateral has an external angle over here. And this angle is the opposite to it. They are equal. But as I said, if you want, you could say, okay, this angle here, these two add up to 180. So you try to find this one first by doing 180 minus the 60 because of angles on a straight line. You're gonna get the 120. Then this now is gonna be 180 minus the 120 to give you 60. But I prefer to do the mathematics the easy way, which is to say that this angle is equal to the 60 out here because it is the opposite interior angle of this exterior angle of that cyclic quadrilateral. So it is 60 degrees. This is 60 degrees. More things you know, the better. All right, so I'm going to say that this angle is simply equal to 60 degrees. Why? Because the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So the 60 degrees exterior and the opposite interior is equal to that 60. That's why it is 60. But the online okay with that?
I think so.
Huh?
Yes.
If
Yes,
you
sir.
if you prefer to do the total angle on a straight line first and get the 120 degree here, and then say the opposite angles here add up to 180 degrees and get the 60 degree here, so that way, no problem.
Sir,
All right? Yes?
can you do another one like this after?
Problem. I don't know if I'm gonna find. I don't know specifically. We can look. Look, I don't know specifically where I'm gonna find another exact one like this. Right? But this is 60 degrees. All right. Let's continue. I'll put it this way. You all send me a message. If you have a question you want me to do for you, you can send me a message on my WhatsApp. My number is 881-5600. You can WhatsApp me at that number. And if you find a question that you want me to explain, send it to me here. And I'll see how best I can work it out for you or send you the solution for it. All right? 881-5600. WhatsApp me at that number. All right? All right. All right, let's continue. Next question is angle. Okay. Next angle I want us to find is the obtuse angle POR, where O is the center of the circle. And notice this diagram did not show the angle, the center point O. It did not show O. All right? I'm going to take this off. I'm going to take off the 60 degrees here just because I want to show this thing. So they're asking us for the angle POR, and they did not show the O on the diagram. So you want to see it. So you have to basically sort of estimate where the O would be. So I'm going to put in like a diameter here, a diameter here. So it means that the O might be somewhere there, right? Just kind of estimate where it is. So this may be where the center is. And this is where the O would be, this mark. And the question is asking us for angle POR. So I have to draw it in to show it. So I draw on that line, and draw that line. So the question is really asking us for this angle right here. Now you have to recognize that that's an angle at the center. So you must be thinking center rule. Once you want an angle at the center, or angle at the center is involved, you must be thinking center rule. Angle at center is twice angle at circumference. So look at the process now. Again, I'm trying to find this angle. I'm going to come back and find what is subtending that angle. I come back here and come back here. There's no chord shown there. It is this arc that I'm marking out in green that is subtending that angle at the center. The same arc from day one, the same arc from day one is subtending this 75 degrees at the circumference up here, or the original one that was given up here. The same arc is subtending that angle at the circumference. Again, if you want, you can put in the chord so you can see it. Angle at center is twice angle at the circumference when they are subtended by the same arc. Let me put the arc in a different color for you. This purple arc is what is subtending that red angle at the center that we want. The same arc is subtending that green angle at the circumference. The one at the center is twice. So this angle that I want right here is 2 times the 75 degrees. Because the angle at the center is twice the angle at the circumference. They are subtended by the same arc. So that angle that I want is 150 degrees. But I go to that?
Yes, sir.
Beautiful. Not just so that angle is 2 times 75 degrees. I want to write it here. So this angle that I want is 2 times 75 degrees, which is 150 degrees. Why? Because angle at center is twice angle at circumference. That is it. Anything else? That question done. All right. What time is it now? We're going to have 15 minutes. One more question can be done in 15 minutes.
Yes, sir.
Shh. Don't want to hear nothing. Quiet. Do like Farzan. All right. Let me see if you can find a nice one. January 2023. Let's go. January 2023. Last year, January 2023, right here. More maths equals better maths every time. every time. Study hard, pass easily. Study hard, pass easily. Let's go. I want to finish with this one, all right? So like I need to make the marathon just 3 hours then, everybody a ball. So tomorrow we make the marathon just 3 hours. You can't manage the 5-hour marathon. So I'm going to go marathon at 12 hours. I'm going to go to the marathon there. Some people have put on marathon for 12 hours and all them things. They want to go. Huh? I'm not a ball. All right, look at this question. How is this question set up? Part A and a part B. 2023. Look at how this question set up. This question said, WX and U are points on the circumference of a circle. TV is a tangent. This is a tangent here. The circle at U, it says UW is a diameter. That's a diameter. Remember, diameter subtends 90 degrees, right? Diameter subtends 90 degrees at the circumference. Right? And then this thing is an isosceles triangle. This is an isosceles triangle. So since that's an isosceles triangle, that means that this angle down here is the same as that angle up here. The sides opposite the equal sides. The angles opposite the equal sides are equal. So these two angles equal, right? That's what we know. Then we have this angle out here, angle Z. Question says, using appropriate theorem, state 3 reasons to explain why angle Z is 45 degrees. So them set up this question. They tell you that this angle is 45 degrees, and you must give them 3 different reasons why it is 45 degrees. 3 reasons why this angle is 45 degrees. 3 reasons. See there? Reason 1, reason 2, and reason 3. All right, let's look at it. Let's look at it. First thing I recognize is that this angle is 90 degrees, don't it? Because it's obtained by a diameter, don't it? Let's put some other reasons up here for them. And see which three we need to list down here. So that angle is 90 degrees. I don't establish that at 45 better now. So this angle is 90 degrees. Let's put it here so. That angle is 90 degrees because it's obtained by diameter. All right? So that angle is 90 degrees. So this angle is WX. WX what? WXU. WXU is 90 degrees, obtained by diameter. Let's put it here so. Angle WXU equals 90 degrees. Why? It is subtended by the diameter. Then, since that angle is 90 degrees, these two angles equal to 45, don't it? Because they're equal to 90, they sum 90. Because if this one is 90, then these two must add up to 90, and they are equal. That's the isosceles triangle we're going to use now, right? So these two angles each equal 45 degrees. We can name them now. So to make it easy for ourselves, we can actually name them. Call this alpha on the diagram. You're free to do these things to make the work easier for yourself. So I can call this angle alpha and call this alpha as well. And then I'm going to say alpha on my diagram is 180 degrees minus 90 degrees divided by 2. So the alpha is 45 degrees. What's the reason? It's an isosceles triangle. Isosceles triangle, right? So isosceles triangle. I think from there now we can find 3 reasons. Having done that, we can find 3 reasons now. We can write 3 reasons easily now. 3 rules to show why this angle is 45 degrees. Because we just worked out that this angle is 45 and this angle up here is also 45. All right, let's write 3 rules now, 3 reasons. First reason, the angle between this tangent and this radius is 90. And if inside here so is 45, then this has to be 45. See that? Tangent and radius rule. That's what I'm going to tell them first. Give them that one first. So I'm going to say the Z angle. I'm going to say the Z angle becomes 90 degrees minus 45 degrees, which is 45 degrees. And I'm going to give him the tangent and the radius rule for that one. Angle between tangent, this time I'm going to need a tangent. The tangent is VU. VU and radius. I'm going to name the radius this time. The radius is, I'm putting an O right here, so for them, I help them. I'm putting an O right here. Can do that on the diagram now. Leave it up. And radius UO is 90 degrees. And between tangent and radius is 90 degrees. That's the first reason. Second reason, I'm going to give them tangent. I'm going to give them tangent and chord rule right here. Tangent and chord. Angle between a tangent and a chord is equal to the angle subtended by the chord up there. That's what I'm going to give them next. So because the angle between the tangent and the chord is Z, and the chord subtends 45, then this angle is 45. I'm going to give them that as my next reason. So I'm going to say, and can I run them two boys on the stuff for me? Hey, students over there, now go outside and stop the noise now. All right, so I'm going to say that the angle Z degrees is also 45 degrees because of a tangent and chord rule. Angle between tangent and this tangent is UV again, and chord, and this chord is UX. UX equals angle subtended, I'm going to write CUB for subtended, by the chord. By the chord. That's my second reason. What's a third reason I can give them? A third reason I can give them, you know, is that total angle on a straight line is 180. And over here so is 90. So I'm going to tell him also that over here so is 90. So let's do that as well. To complete the reason. I'm going to tell him that this is also 90 because the tangent and this radius is 90 degrees. I'm going to tell him that as well. So this angle over here is 90 degrees. So that's angle TUO. Let's put that up here. Angle TUO is 90 degrees because it's the angle between the tangent and the radius. Right here is 90. Then I'm going to say total angle on this straight line is 180. So since this is 90, let me write it there. Since this is 90 degrees and this is 45 degrees, then this has to be 180 minus the sum of these two, which is going to give a 45 as well. Let's write it down. So that angle Z, again, becomes 180 degrees minus the sum of the 90 degree and the 45 degrees, which comes back still to 45 degrees. But this time I'm using the straight line. Total angle on the straight line, TUV, is 180 degrees. That's the reason. Total angle on straight line TUV, the straight line TUV, I'm talking about through the point O, TUV through O. Through U, sorry, through U, through the point U, is 180 degrees. So I'll give them three reasons But I had to support it with this up here. I don't know any other way to do it because I can't fit all of that in these little spaces down here. So put some supporting information up here beside the diagram, which you are free to do. And then you put your reasons down there. 3 marks. We want the 3 marks. Looks like a lot of work for 3 marks, but you want it. All right. Circle theory now. Finishing strong. Finishing strong. This question says, the diagram below shows a circle with a diameter KF. Okay, so we get a diameter question here now. Diameter KF. The line EFG is a tangent. That's a tangent to the circle at F. The points F, H, K, and J lie on the circumference. F, H, K, and J, they lie on the circumference, but they don't show us any cyclic quadrilateral there. All right? It says, by showing each step in your work where appropriate, find the value for each of the following angles. Angle X right here first. All right? Angle X. All right, so I want this angle here first. What do you do again if I want to find this angle X? What's the process? Come back and find the chord that is subtending the angle. Come all the way back. The chord subtending that angle is this chord. What else is the chord doing? That same chord is subtending this 56 degrees up here. See it there? The same chord is subtending 56 degrees up here, the circumference. So it means that these two angles equal. Same segment rule. Same segment rule. Angles in the same segment are equal. So it means that X is 56. So angle X is 56 degrees. Because angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. If you want to write that additionally, no problem. But I totally believe that if you just wrote that, they're going to give you your marks. Next one. Angle Y. Let's put on the 56. So we now know that this is 56. This is 56. Angle Y right here. Easy. This is an external angle of this triangle. See it? It's this triangle. I have the extension of one side. Let's draw it. Let's look at it. Angle Y is an extension of this triangle. So it's an exterior angle. Let's look at it. See it here? I'll go like that and draw the triangle and show the triangle in red. Then I extend this side and then form the angle with the adjacent side to the extension, to the extended side. Then this becomes an exterior angle. That exterior angle is equal to the sum of the two opposite interior angles. So this angle out here is a dependent of the final. Is equal to this angle plus this angle. That exterior angle is equal to those two, the sum of those two. Let me draw it another way. So this angle here that I want is equal to this one plus that one. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. So the Y is equal to 56 plus 19. Now some persons might go the other way and go total angle on a straight line is 180 first, and, right? To find this one and find this one. Oh, well, you might find this one first by saying total angle in this triangle is 180 and then subtract back from 180 to get that one. But the quick way is to recognize that this angle out here is the exterior equal to the sum of the two opposite interior angles. So the y actually is 56 plus 19, put on the degrees. How much is that?
75.
75 degrees. So the y degrees is 75 degrees. So see here, this angle is 75 degrees. Why? Because the exterior or external angle of the triangle is equal to or equals the sum of the two opposite interior angles. This means interior, this means exterior. That's the reason. Anything else? Question done. And that is that. All right, guys. We'll do another one tomorrow. And we'll do one next week. The one in the last week is gonna be for 12 hours, 9 a.m. to 9 p.m. You're gonna be doing 2 exam papers.
Okay,
you're
sir.
gonna do one, I work it out, and then gonna do another one, and I work it out, and then that's it. And then the Sunday before the exam, we're gonna have a session where you bring whatever you want me to explain for the last time. All right, that's the plan. Huh? Yeah, anything you want me to explain the day before the exam, you come with it. That's what we're doing for about 4 hours. All right, guys. See you all tomorrow. Online people, you good?
Okay, sir. Yeah.
Yes, sir.
All right. Gonna join tomorrow?
Yeah.
Yes, sir.
All right, no problem. Remember, if you have any questions you want me to work out for you, you can send me a message, okay?
Okay, sir. And thank you
No
so
problem.
much.
Yeah, man, no problem. Any question you want me to work out for you, anything you don't understand, send me a WhatsApp message. You have my number?
Yes, sir.
You have my number, 881-5600. Just send me a WhatsApp message if you have a
Sir, I
question.
have your number. Remember, you went through our SBA, so yeah, I have your number.
Oh, all right, good.
Good
All
night,
right,
sir.
bye, everybody. All right, good night. Yeah, man, it was good. I'm gonna end it now. So tomorrow I send another link. I'll try and see if I can use the same what you call it, the same idea and stuff. I don't know if it's possible, but I'll see. All right, bye.